taken by A.C. Nelson. So I have taken you lean for 2 years from the university, worked for them, and our projects were at Australia and New Zealand as well as in India. With several of the other companies and other things, so we can share and discuss our knowledge, and we can go ahead. What is the things which this my talk will cover with respect to the statistical analysis when we are using the data collection. So when we are doing that, the first question arises: why do we need statistical analysis at all? If there is no statistical analysis, what is going to wrong? Most of the social scientists earlier, long back, when I taken my career in 1940s, 40 years back, 1980s, at that time, there was a lot of debate on that. At the time, in fact, more association with Professor Pathak and S.N. Singh also. They were our Board of Studies members earlier. So they used to come to our university when I was a student as well as a research scholar in this department, and I had a lot of association with IAPS. So at that time, we had a lot of discussions on that. Why this rigorous mathematics? Why don't we have a simple part of thing, and actually the social phenomenon is more important to be taken care. But what about of these numbers and models and how they will be more effective? But later on, the emphasis has slowly shifted to applied statistics from theoretical statistics too. So more utilizing the models for inferential aspects. That was the actual phenomenon, and that is in the right direction. It was taken care, and in fact, many of the demographic phenomena and principles now turned out to be business demography is the more important. The trust area in demography, most of the thing is business demography. Business demography does not mean only the insurances and premiums and that part of the thing. It goes to any part of the consultancy works that goes ahead with respect to business demography. And when we look into that, we can see why the statistical analysis. The first part, if you see, there is a perception. When we start with a project, when we work with a project, we have some queries, we have certain objectives. When there is an objective comes, the sub-objectives and objectives will be in mind, working them, and we have a perception. With a perception, we will start with any of that work. In reality, the perception will give us a part of hypothesis. The perception may be with experiences, maybe with the knowledge that we have already with the subject matter, with the earlier studies. That will put us to look into that perception. The perception will keep us as a hypothesis. But do that perception will be reality with respect to the prevailing situation, with respect to the conditions and constraints that was prevailing at that part? This is a very interesting and important thing. How do we differentiate whether the perception is a reality or not? To do that, data-driven approach is more important. So for that, statistical analysis is the most important consideration, where we have to go for that. And another very important thing is to gather facts for a good decision making. For any professionalism, decision making is the most important consideration. We all agree with that. And when we want to take a decision at the right time, right decision, how can we take a right decision at the right time? Unless we have certain facts. How to gather the facts, how to generate the facts, how to get the facts. Because there is a lot of information, data. Huge data is available. Nowadays, in every format, every part, huge data. From the data, we have to convert as information. Information will transform as a knowledge. Knowledge will provide the wisdom. So to get the wisdom is for decision making. To get that wisdom, the starting is data. Data to conversion as information, information to knowledge, knowledge automatically gives the wisdom. So this process of transformation goes by statistical analysis. For that, we require. Another very important thing is, several times we have to understand the processes. To understand the process, how do we? We have to characterize each and every process, every phenomenon that was prevailing. How to characterize? How to make it as important features that will be there? Which features are more important? How to take these features? That part, to have the understanding of the processes more and more clearly and clearly, one has to take this part of statistical analysis. The next part is characterizing the processes. That's what exactly the earlier one. Unless you characterize, you cannot understand the process. And the next one is, we have a process or a procedure or a methodology or a phenomenon that was there. But as we can see, whether it fit to use or not, whether it fit to the considerations that were prevailing there. Suppose we have developed a policy. Is it the policy is feasible? Is it practically implementable or not? This validation beforehand, before implementing the policy, before implementing the procedures, before taking care about those part of the thing what we have in strategical development that was taken. And implementing and it is not possible, then we say we cannot be able to do and we have to modify and all these things. After that is of no use. Beforehand only we have to do that. How to do that? Statistical analysis will give us that part. That's why we require statistics. And very, very important, there are many of the process performances, where first time we have to study, first time we have to create, for the first time we have to talk about, then we require a benchmark, a baseline. How to create that benchmark and baseline? There is no benchmark, no base mark for that. It is a very entire new phenomenon, new philosophy we want to brought in. But how to take that benchmark? For that, our statistical analysis will provide the methodology to design the benchmarks and baselines. So these are the things. Not only these things, there are several other advantages. There may be trivial many factors which will be influencing. There will be trivial many, but only a vital few will be effective. How to identify these vital few among the trivial many? That can be done by our statistical analysis. That's why we will be taking care about the statistical analysis is most important. We take into that every discipline, whatever may be the discipline we study, we take, we work. Statistics works as an infrastructure. Statistics is an infrastructure for that discipline. We have now. We will go with a few parts: data, statistical regularity, sampling error, sampling design, determination of the sample size, which is very important in many of the parts, because many of the social scientists as well as the engineers, they take about the sample size. If it is not properly designed, properly taken care, there is a lot of differences in the inferences we make out. And another is testing of hypothesis, then a little about regression analysis. This part we will be taking care. Up to what time I can take?
10 to 11:30, sir.
11:30, okay. Just 1 more hour. Quickly I will go through it and I will share my thought process in this. For taking it, this is the origin for statistical analysis. For any statistical analysis, what is very important? Data analysis, deductive logic and inductive logic. These are the very important considerations. For any part of the thing, logic is of two types we know. philosophy. Philosophy is the origin for logic. That's why any discipline, doctorate degree is given, doctor of philosophy. That is, you understand the logic of that discipline. The philosophy itself is logic. So the philosophy is two types. One is deductive logic, the other is inductive logic. Deductive is we deduce. What we deduce? We study the whole universe. An element belongs to that universe. And we attribute all the universal characters to that element. We study the universe first. From universe to element. Real number system in mathematics, if we call. We know the properties of the real number system. If an element belongs to being a real number, that real number possesses all the properties of that real number system. Similarly, we have several of the parts. But coming to the other one, the inductive logic. Inductive logic is studying only a part, inferring about the whole universe. We study a part, infer about the whole universe. Most of the statistical analysis deals with inductive logic. We study a part, infer about. That's why we should be very, very careful. We should be very careful when we handle the statistical analysis. Because we are studying only a part and inferring about the whole population, whole universe. That is what we have. So how we will be doing that? We will take care about y equals to f of x. What is this f and what is this x? What is this y? Usually, we want to establish a structural relationship between the variables. Between the variables, we should have a structural relationship. If you understand the structural relationship, everything you can dig from that. The basic phenomenon for any statistical analysis is understanding the structural relationship. How do we understand the structural relationship? That F. How to get that structural relationship? F is the functional form. So, hold the either qualitative or quantitative variables. You have to take care about the functional relationship. So that functional relationship is possible by using our statistical phenomenon. Everything is very simple. Our whole analysis is very easy. Not moving. Yeah. Okay. We all quickly, before I go it as a format, I will talk about, you all be knowing population sample and sampling. I'm not talking more on that because you are more involved in that from day one to every day. You are doing that. Coming to the other two, statistical regularity. That is most important. Very important fundamental concept for doing the statistical analysis is the statistical regularity. The principles given by Fisher more strongly. Galvinova is the first man to talk about statistical regularity, but Fisher has emphasized this more effectively. And law of statistical regularity. The law of statistical regularity is that a group of objects chosen at random from a large sample tends to possess the characters of that large group. This is the phenomenon. If you take your large sample, your sample is large, a part. What we are taking a sample? A part of the whole population. If your population, that part is large, that reflect, that will be a good representative of the population. That is the first fundamental principle starts from there. As much as possible, your sample size should be large. Second one, random selection. There is no bias in selecting the element into the sample. There should be no bias at all. If bias is there, then convenience and other things will go. It is not statistical analysis. So without bias, we have to do the analysis. Like a judgment. As a judge gives a judgment without any bias, when he sits in the judge chair, like that a statistical analysis should go as without bias. If no bias you want to take, it should be a random selection. It should be a random selection. These two are the very, very important fundamental considerations for our statistical analysis. Sample size should be large. Here, large. How large? That's a very big question. How large? For somebody, 20 may be large. Somebody, 1,000 may be small. How large it should be? That is what the sample size should be determined with a principles of the statistical part, statistical regularity. So that is what we will take care. It's not working. Again. Maybe battery gone. I will operate from there. That may be better. Don't worry. Idena? Okay. Okay. So, population, sample, inference. We all know that, how we will be drawing it. I need not go more on this. Then the advantages of taking a sample. We all know that. It is very accurate, academic in nature, very reliable, and it takes less time. Where it is the law, practical methods of collecting the data is what? Well done. Disadvantages are also there with respect to the sampling. When we go for sampling in that, just no battery much. Okay. When we are having these advantages and disadvantages, very important consideration. Yeah. Yeah, I will go ahead. That's what exactly. It is very important. Is it always required to go for sample for every study? When we have to go for complete enumeration, when we go for a part and take care about it. This is very important consideration. Because the complete enumeration, we know we are collecting information from each and every element of the population. But coming to the sample, we are taking only a part. When to take part? No doubt, sample have some advantages. Complete enumeration has advantages. But when to go? When the population size is small, reasonably handled. When the population size is small and reasonably handled, then we can go for complete enumeration provided the sample does not distract, the measurement does not distract the population element. That is very important. Even though it is very small, if your complete enumeration by collecting the measurements or by doing that and by analyzing the element goes distracted, then we cannot reduce. Already the population is small. So if you take again all the population elements and measure them, nothing will be there to take care. But if most of the social sciences and other part of the things, it is not a destructive, unless in manufacturing units. like electrical bulb. We want to estimate the lifetime of the bulb, a new bulb that was very, very costly and taken care. Then if I go for complete enumeration of all the bulbs that was produced, no use. And also it is time consuming. Already I mentioned. So sample will come only when your population size is small. That is the very important. Suppose I have only 40 employees in my organization. I want to take the satisfaction survey of my employees. 40 is not a bigger number. I need not go for sample and again doing that. Even if I do, my sample size determined to take 25 or 30 even out of 40 by taking the statistical principles. Not 5%, 10% like haphazard numbers people used to take sometimes. I have taken 5% of sample, 10% of sample, which is meaningless as per statistical sense. For sample size should be determined based on statistical regularity, statistical principles, your level of confidence and tolerances that I'm shortly going to discuss. So complete enumeration. When we have to take, when the population size is small and able to handle each and every observation, then you have to go for that. And when the sample is very large, very big, then going for that. In fact, we have two types of populations we know. One is a finite population, the other is a infinite population. For infinite population, infinite here, relativity, that one has to keep in mind. Even though some are infinite, really infinite, the fish in a sea, it is really infinite. We cannot go on counting them and saying this much number of fish are there in the sea. But if the number is very, very large, then we say it is infinite population. And finite population is when countably possible, the population. Why that finite or infinite is very important for a population, finite population or infinite population? For a finite population, we have a sampling frame. You have a sampling frame. You can list out all the list of elements in the population. List of elements in the population, once you have listed out, you could be able to take a part of it. For that, it will be. So when we are taking it, the sample, the data collection, when we take it. Here I would also like to mention two things. The data collection is of two types. One is a controlled collection, the other is an uncontrolled collection. Controlled is design of experiments. You can design the experiment under the specified conditions and under the specified constraints that was there. Under the required treatments, you will collect the information. You have to do that. In most of the medical phenomenon, we have controls. All the population that was there as it is, we cannot take it. We have certain conditions, constraints, certain features, certain disease embedded in that. From that, we have to study the medical diagnosis part of the thing. Their controls are more important. An experiment is to be carried out with respect to. When I conduct the experiment, that is a different. Here I am not going to discuss more on that designs of experiment. The other one is uncontrolled. Because the measurement, the response that you can control, you are not controlling under the specified conditions or constraints or treatments or that part. What as it is existing with them, you are collecting from that uncontrolled methodology. So sampling will be coming out under uncontrolled part of the thing. Whereas controlled is designs of experiments, and there is the other way, it is following the cases, case studies. Case studies is another. Unless or otherwise very, very small, we don't go for case study analysis. So when we are taking the sample, it should be three important concepts that you have to keep in mind when a sample is taken. The first one is nothing but of taking care about the representation. The sample must be a good representative of the population, we all agree. How good it is? It should be good. Good means it should represent properly. A good representation. That is, every character of the population should be represented by sample. That is the very important. Every character that was depicted by your population should be represented in the sample. The second one is generalization. By taking a sample, you are inferring about the whole universe, inductive logic. So it is feasible for generalization. The sample should be taken, whatever you have taken, that should be feasible for generalization. Third one is taking care about looking into the third one. You are taking only a part, inferring about the whole universe. There is an error you cannot avoid by taking a part of it. So this error should be controlled. Error should be minimum as far as possible. These are the three important concepts that are very much important when we choose a sample. So the sampling error, as the sample size increases, error decreases. So the basic consideration is that. Then where a sample should be, we know there are two important ways people usually go. The first one is random sampling. The second one is non-random sampling. But scientific methodology always take care about statistical analysis with random sampling. Probabilistic sampling is the best method. You have to go for that. But we cannot insist always. I want to collect the information and exit polls. If I go on saying that I will collect that in a very, very robust probabilistic manner, it may not be possible for me. Probabilistic manner, I can prepare a sample frame, taking all the list of voters who are coming out, and there I take a sample, sit at the poll booth. When they are coming out, I want to collect the people whom I got selected may not come out. He may not come even voting. What is the use with that? It is not possible. There I have to go for non-probabilistic sampling only. No other option we have. So, because why we have to go for pretty well knowing as a statistical analyst, non-probabilistic sampling is not useful, not good, not much better, but still I want to have some information. Some information should be there to do that. Instead of not to have anything, we should take some information, refine that information again and again, revalidate, that is resample, take a large non-sample, non-probabilistic sample. From that, generate a sample with random nature. That will be providing you a better estimate. What? Exit polls will do that. Exit polls will do, first they take non-probabilistic sample. Then they generate again and again. More samples will be generated. Repeated sampling. Concept is induced in that. Convert that non-probabilistic sample as a random sample. That is what we have. And the methods usually we have simple random sampling, systematic random sample, stratified random sample, multi-stage sample, cluster samples. There are several other methods. I just listed only a few which commonly used for the purpose of our surveys and other things, multi-stage as well as these are the part, and non-probabilistic convenience purposive quota. These are the very important considerations. And quickly I will go for that because I have to talk even something on my favorite subject, testing of hypothesis. So, random sampling, we know what is a random sample. Everybody knows that. What is that? Giving equal importance to each and every observation to enter into the sample. Population element, every population element has equal chance. The chance is not varied. Equal chance is given for each and every element to enter into this. Therefore, we will have the random sample. Random sample is very simple. We have a sample frame. From the sample frame, we have to select randomly, giving chance, equal chance, lottery system, random numbers. Several of these methods, we all know that. But when to use random sample, that is very important. What is the basic assumption? What is the basic assumption we are making for a random sample? The population is homogeneous. The population, all elements in the population are homogeneous. They depict to be the same. For collecting the samples, the basic random samples, the basic philosophy is two things, the variability. Two things are dependent on the variability. What is that? Homogeneity, heterogeneity. Homogeneity and heterogeneity. This is the very important consideration for choosing which methodology is to be selected. Which methodology is to be selected depends only on that. You have to see what is the population nature. Nature of the population is very, very important. All elements are homogeneous, basically. Homogeneous in the sense, the variability is what is that?
Homogeneity.
Yeah?
Homogeneity.
Homogeneity.
Guarantee that all the sum for all the
Here, very important thing, homogeneity, what I said is variability. Within the subgroups of that, they must have same variability. The variability should be the more or less same. Same in the sense, statistical sense, subject to certain interval. Precision.
so what I am saying, suppose we have stratified
Yeah.
and we have subgroups.
Yeah.
And we are believed as per the taught of our statistical method.
Yeah.
Okay, what we are taught? We are taught that we have divided according to homogeneous groups. Then this particular homogeneous group will generalize the
Whole population.
So my question is,
Yeah.
this particular group gives guarantee that it is all the subgroups. Suppose there is 1,000 particular subgroup sample. They all have the same characteristics.
Yeah,
Same
I will tell you.
experience.
I will tell you.
Same anything.
I will tell you, not the same age or same character in that. With respect to the variable under study, here the very important consideration is which variable you want to estimate, which variable you want to take the inferences, on which variable you want to take group of variables, one variable or group of variables. Put together those set of variables, they should be more homogeneous. For example, I will tell you, if I want to collect in a classroom, the sample of our Andhra University students. There are 10,000 students. If I take one important variable like their intelligence quotient, earlier there was a debate, now that was cleared. There is no gender parity. All students has equal opportunity to have the same intelligence quotient. Okay? With respect to intelligence quotient, male or female, whatever may be, only the variable is taken. All the 10,000 students is a representative. They are homogeneous because they are given the admission based on their admission test, based on their marks, based on their performance. These are the things. Or even if you take that, the intelligence quotient, they are given the training, same methodology, same part of thing. Here, the variability may be there, but it is within the limits. Okay? The variability. But just 1 minute. When it comes to the height of the student, the variable is height. Pretty well we know, two groups are there. One is ladies, the other is gentlemen. Okay? We know male and female. Males are shorter than, males are longer than females. So two groups, distinctive groups. So with respect to that variable, there is a parity. Parity will come. Okay? So now you can tell.
Just I am asking, suppose we have our own perception,
Yeah.
and we have, suppose we have 10 to 15 adolescent group. Suppose you are talking about the girls or student of your university.
Yeah.
You classify or you take this sample of a statistical department or any department of any university. This group has the same character. These are the sample. Suppose you subgroup all different groups. Women group, girls group, boys groups, staff group, official groups, faculty groups. So you have subdivided different groups according to the homogeneity as you perceive.
No, that is not our perception. Perception does not work in selecting the sample. Perception does not come into that. It is the fact that should come into the way. How the fact? The variability is the measure. The variability is the measure which you have to take care. So the variances of the subgroups, that you have to consider to decide the homogeneity. Your perception may add to take care about the variability. But when you go for homogeneity, non-homogeneity of the population, beforehand you cannot take it. You must have some additional information. For every statistical study of the sample study, you have to depend on additional information. For example, now recently, the earlier people thought the homogeneity is with respect to the variability. Now the concept has changed 20 years back. When market research was more rigorous now, it is the quotient of variation, not the variability. Now even for sample size determination also, earlier Cochrane and other give as the formula with respect to the more emphasis on variability. Now the variability has changed, relative standard error. That is your quotient of variation will be coming into the picture. So there is a change, advanced level. So it is the quotient of variation that you have to take care. If the quotient of variation is within the limit, within the range, they are more homogeneous. It is not our perception that will speak out. Whenever you have a population, don't take by your perceptions. Perception in the first line of statistical analysis goes, you have started with a perception, but your analysis should be more scientific. Scientific in the sense, you should have a measures of statistical consideration, metrics. You have to depend on metric. So measure the quotient of variation with respect to that. Yeah. Yes.
Comparability.
Variability. That's what exactly you are right. That's what I'm telling. Yeah.
1 lakh, but
Yeah.
population of crores.
Yeah.
In that case, 1 lakh will be smaller.
Yes. That's what exactly the very important reason. That's why last 20-25 years, the entire surveys, particularly in market research, they are very careful and very shrewd about it. Because when a product is brought into the market, they have to take care about it. So they will be taking more serious on quotient of variation now to determine the samples and sample sizes and other things with respect to determine the heterogeneity and homogeneity. But still most of the social sciences studies, what I have gone through and seen that, follows the variance. But this is the advanced part of the thing, quotient of variation, that is to be taken care in that. In fact, J.N.K. Rao, in his book, recently edited book, he has changed that part.
That's the difference between variable is that when you are measuring coefficient of variation, you actually standardize the variable.
Yeah, exactly.
Then you take the variable.
Yeah. That's the advantage. But earlier we have not thought of that. Long back when I studied my sampling 40 years back in 1980s, my teachers has not taught us that. It was the coefficient of variation is used for some other purpose, to know the consistencies. But now the consistency is the more important for homogeneity. So this is the random sample. But here one important thing. When we are having a finite population, when we are giving equal importance to each and every element to enter into my sample, there are two ways it will come. With replacement, without replacement. The typical nature you can understand here. With replacement, if I take, what will happen? I am giving equal importance to each and every element, the probability remains the same. But what is wrong? My sample size will reduce. repeated samples will come. If the repeated samples are there, I have decided with a consideration of using all the statistical principles which we are going to look into that determination of the sample size. And with that principle, I should have 50 observations. But with replacement, I got 10 observations repeated. What happened? The information only on 40. So my optimal sample size is not there. That is the basic drawback. That's why without replacement is more advantageous rather than with replacement. Without replacement, one has to go in simple random sample without replacement phenomenon. Okay? And then, very interesting, very interesting, heterogeneity, homogeneity we talk about. We have taken that population is homogeneous, then fine. But there is a stratifying factor which is very much clearly known to us with the earlier studies or earlier considerations, or we have whatever part of the earlier information that was there with the subjectual knowledge. The subgroups within the population, they are not homogeneous. They are not within the group, they are more homogeneous, but between the groups, they are heterogeneous. Within the group, they are homogeneous. Like height, with respect to whatever I am talking about, it is with respect to the variable under study. That is very important. Variable under study. Suppose my variable under study is the height of the student. Height of the student. Okay, people may get why height of the student is important for a classroom. To design my classroom, the chair of the, very important. The chair is decided, length of the chair is decided, usually, how it will be decided? Median. Median of the subgroups. The median of the subgroups of the knee height. Knee height, that is very important, because if your knee height is, you are very tall, you have a very high knee height. If you are sitting on a small bench, what will happen? You have to bend your knee. You cannot sit comfortably for a longer period. Suppose you are a short, knee height is small, your bench is an average height, then what will happen? Your legs will be hanging. Where inconvenience will be there, you cannot sit along. So the knee height matters. When we design the classroom, now it is the mixing of classrooms are giving, that is not ideal. The Stanford University now decided last year to have the separate chair and benches for the gender parity. Gender parity, to have more convenience. If they are interested, they can choose. The choice is given, equal opportunity, but not for differentiating the gender, to give more comfort to the gender. They have decided that. That was taken in the last year in the Stanford University. They have designed the how the classroom should be designed. Taking, earlier it was the semicircled. The design should be semicircled, not like a straight line. That was the arrangements. Lot of advancements comes based on statistical methodologies, evolving on that. Here, when we are taking the systematic we game, yeah, stratified I want to go. No. Random. Stratified. First I will talk, then I will come back to systematic, stratified. So in the stratified, the groups are more important. So we have to segregate. Segregating and each. When we are segregating and taking that, within the group they are more homogeneous. Between the groups they are heterogeneous. Heterogeneity should be between the groups. Within the group they are more homogeneous. When they are more homogeneous, simple random sample will be sufficient. So within the group take a simple random sample. But when you take into that, how you will choose the groups? How to take the groups? That should be proportionate. Proportionate to the population size. Proportionate to the population size. At least covering one element of each and every group. At least one element must be there in each and every rule. So you have to take proportional allocation. Of course, later the proportional allocation may not be very comfortable in some cases. That was argued by Niemann. Niemann allocation. What is that? Optimal allocation. The optimal allocation is based on cost. Cost of getting the sample. That matters much because sample surveys, they are not very easy. They are time consuming and costly. Time may also be converted as a cost sometimes. So whatever you have that cost constraint, and you see that cost is very, very important. Also give weightage for cost in addition to proportionation. In addition to proportionation, give the cost. That's why in the format of cost consideration, they take the subgroup sizes along with cost. Okay? Suppose another part of the cost is, along with the cost, the variability is also considered. The variability of the subgroups, because heterogeneity is the more consideration. So within the subgroup size, how we have to decide? That is what we call optimal allocation. Niemann's allocation is also known as optimal allocation. Optimization, bringing the optimization of the cost as well as the variability into the picture and taking care about it. Without bothered about the cost. You say that cost is not matters, but the size is very important and we have to go for that. Then proportional allocation is sufficient. You need not bother about. But cost is very important. You have to go for Niemann allocation in stratified random sampling. These are sample. Then very important, cluster. This cluster, what is that? Contrary to your stratified random sampling. Cluster sample is little contrary. What is contrary? Between the groups, they are more heterogeneous. Within the groups, they are more homogeneous. Between the groups, heterogeneous. Within the group, more homogeneous. Then take clusters. Take the whole cluster, enumerate. Take the whole cluster and enumerate. Clusters you have to take. So cluster sampling will be more effective when within the group they are heterogeneous. Between the groups, they are more homogeneous. So cluster sample has some advantage in many of the, in fact, I think in student surveys. Because student surveys, the departments, the discipline, within the disciplines, they may be more homogeneous. In the discipline itself, within the discipline, they are more heterogeneous because more different types of groups, different types of students, different natures of that, different profiles of the students will be there. But between the groups, in each department, same type of compositions will come. So they are more homogeneous. Clusters is to be taken in that part of this thing. And once you have this cluster sampling, then you can go for the first one, which I have skipped it, systematic. This is very important. This is when we have to go for that. When your sample frame is not complete. Sometimes it is very difficult to formulate the sample frame, even though finite sample is there. Writing each and every element of the sample frame is difficult. But we know the structure of the households, structure of the elements, how the elements are distributed. Suppose in a forest, I want to estimate the timber in a forest. So timber in a forest, when I want to take care about that, there each and every trees will be there. The timber that was obtained from the tree will be different, but trees will be in the format. There may be given numbering, okay? So then what we have to do? We will decide from the sample size into the various segments. In each segment, how the segment will be decided based on the total number of samples I want and total population. I know the total population, I know the number of segments where I want to have. Each segment I have to take. So first segment I will take random. That's why it is called random start sampling. Random start. First segment I will take. Thereafter every kth element. So suppose first 10, I have formulated one segment. From that segment, I will take one randomly. Thereafter, every 10th or 5th or 20th, depending on my sample size, I will go ahead. Suppose I want to have the sample in that, then I can go for linear or a circular. Again, connect back. Connect back means I cannot change the entire structure of the forest. I will take only on the numbering. The last number again comes to the first one, linked to that. That is what we have to take care. So this is the cluster. Cluster sample, systematic sampling, random start. Random start is the most important sample used for many of the household surveys. Household surveys. And recently, in addition to this systematic sample, there is a serpentine sample. Serpentine sampling. You may be well aware of it. So last 2 decades back, this concept was introduced. Serpentine sampling. What is the serpentine sample? You have a street. So take the left, right. Every street has left and right. Some houses in the left, some houses in the right. Door numbers are given. But usually door numbers according to they go ahead. So there is a part of the thing you have to take one on the left, one on the right. Again with a systematic number. Again come back. That is going from here, come that, going from here and that. What is the advantage with that is the probability that was included of every element in that, not going on that will be more high. The principle of inclusion of the elements from left and right, both, we are giving in that. Even though that we may not consider their heterogeneous group, but more weightage is given. So serpentine sampling was given, but later now it has gone again. It is not used because not much principles have gone. It is more or less systematic sample only. So people have taken the systematic random start sampling only. These are the important sampling methods. Then quickly I will go for sample size determination. Of course, non-sampling I am not talking about. This is one snowball sampling that we may come across, we have to do sometimes with respect to this, that we cannot avoid in some part of the thing. And yeah, quickly before I take the sample size determination, let us take a little about our statistical inference. Because based on the statistical principles only, sample size determination will go. So when we take care about this, the first and fundamental consideration is statistical analysis is a decision science. It is a game. Game between the investigator and the nature. Game between the investigator and nature. There is a true value. Nature has already fixed it. You may believe if the nature, you call nature. If you believe God, God has fixed it. If you believe some supersonic powers, that has fixed it. Whatever it is, I call nature. Okay? Nature has fixed the true value of the parameter. Nature has fixed the true value of the parameter. Statistician taking apart a sample using his statistical theory, a scientific methodology, he has estimated it. He got one estimate value, but true value is there. That is fixed by nature. It won't change. Now, the estimate may be true value, may not be true value. If it's the true value, then your analysis is very good. The statistician wins in the game. If it is not the true value, because he has taken only a part, only a sample, he has estimated. It is not a true value. using all his knowledge, everything he has done, but it differs from the true value. Then he lost. So there is a possibility of errors in your statistical analysis. There is a possibility of error. What are that errors? Type 1 error, type 2 error. The decision, accept or reject null hypothesis. The hypothesis is a statement regarding the population parameter, statistical hypothesis. Statistical hypothesis is nothing but a statement regarding the population parameter. We have estimated and taken and we have find an estimate and there is a true value, whether it is equal to a true value or not. That is our consideration. So here we formulate the null hypothesis. What is that null? There is no difference. Null means difference is zero. Difference is zero, null. So we formulate the null hypothesis. Once we formulate the null hypothesis, the difference, there is no difference in that. Then H0, with respect to H0 only, entire statistical analysis is designed and developed against the alternatives. Against the alternatives. So H0 when we take decision, it may be a correct decision. You have taken, H0 is true, you have accepted. When it is true, accepting it by your statistical test or validity or whatever you say, by your statistical analysis, you have accepted, it is a correct decision. But you have rejected a true hypothesis. Hypothesis is true, but you have rejected. What is that? That is type 1 error. That is your type 1 error. You have committed an error. It is in reality, it is the fact. The null hypothesis is true, but your statistical analysis, you have taken a part, you have obtained an estimate, you have carried out some statistical analysis, told that it is not acceptable. There is a chance that you can do that, isn't it? Because you are taking only a part of it. You are doing it. So there is an error. That error is type 1 error. The other one is your false, your null hypothesis false. You have accepted. Accepted a false null hypothesis. That's also an error. That's also an error. It is called type 2 error. The other one is false hypothesis is rejected. So these are the 4 criteria that will be coming up. Every statistical analysis, this we all know. Now the probabilities, because the entire thing is measured. Quantification. How we will give the quantification to an error? Committing type 1 error is the probability known as level of significance. Known as level of significance. So probability of the second one, type 2 error, is beta. 1 minus beta is the power of your statistical analysis. That gives how powerful you are, if you have that. So this is the basis for going ahead with respect to sample size determination. This we have to keep in mind for every statistical analysis we are doing it. To decide that we have 2 errors, type 1 error, type 2 error. Type 1 error and type 2 error. The probability of occurring each is there. The chance, there is a chance loss governed by loss of chance. So type 1 error and type 2 error. Now sample size determination. So whenever I talk about sample size determination, I recollect back a small story written by Cochrane in his textbook. A small story he has written while explaining the sample size determination. The Cochrane, very famous book for sampling theory, very famous. Of course, there are several other books, no doubt on that, but Cochrane is very standard. He has wrote a small story on that. What he has written is, just I will narrate in 2 minutes that you can better understand how to go for sample size, because that is very interesting. An anthropologist wants to conduct a survey of blood group, person of O positive people in a tribal area. Okay? In a tribal area, how many population are O positive? He wants to have a proportion, estimate the proportion. Then, how much sample size is there to be taken? The whole tribal area, he has a population of more, like 10,000 people. Okay? How much sample he has to take? Is it possible, because it is an anthropology study, out of his interest, he wants to study how many positive, O positive people are there. So he wants to take sample of it, only a sample. How much sample should be decided? That is a big question for him. So he immediately approached a statistician. And he told that, sir, I want to take a sample. Can you help me? The statistician is very fond of helping the others only, because it is only a supportive science. Always statisticians are more happy to help the others. So he told, yes, very interesting. Come, I will definitely give you the size, how much you have to decide. You have to enumerate that. Then what he told is, okay, tell me how much I have to take, my population. What is your population size? 10,000. Good. You want to take O positive. That is your variable. Then what the next? He immediately statistician asked, tell me, what is your confidence level of your study? With what confidence you want to take statistical analysis? What should be your confidence level? He told, what is that confidence level? Then he told, it is a statistics, it is a game. You are playing a game with the nature. So you have to take how much risk you are going to accept. How much risk? Because for every game there is a risk. How much risk you are going to accept? Then he told that, okay, I can take 5% risk. That means 95% confidence you want to have. Fine, 5% risk is there. Good. Then he asked, also the statistician told, good, you have 5% risk you are taking, very nice. Then tell me how much tolerable error you are going to accept. How much tolerable error? What is this error again? You asked me the risk, I told you, but why this tolerable error? Why I have to tolerate? Then he told, you are taking only a sample. You are giving it. How care I can take? You may take in your enumeration, you are not going for the whole universe. You are taking only a part. In addition to risk, there may be an error in estimating, because one sample you take, one estimate you get, another sample you take, another estimate you may get. Estimate may change. Same estimator. Estimator is same. Estimate may change. Since estimate is changing, there is an error in that. How much error that you can tolerate? Tell me. He told that, okay, I can tolerate 4% or 2%. I can tolerate 2 or 4 within the estimate to estimate variation. Now I understand, because one sample not I am taking different sample. Which sample may come, I don't know, you don't know. So I can agree, I can tell you, it may be 2. With my estimate of that proportion, 2% may be tolerable. Fine. Good. Now, do you have any earlier study on this? He has asked. The statistician asked. Do you have gone through any earlier studies on the O positive of a tribal region that you are going on that? Then the anthropologist is fed up with the statistician. I came for your help, but you are harassing me by questions. You are asking each and every question which I am telling that you are doing a sample, I have a risk, I have to accept error and I have to do this and that. What is all this? You don't harass me. If you want to give the sample number, give it, otherwise say that you don't know anything about it. Then immediately the statistician said, don't be angry. If you have any earlier studies, I have just asked. If you don't have any earlier studies, don't worry. We have a better way of doing that. For that also we have a provision, because it is only a proportion. I can take 50% chance. P is 50. Proportionate of people are 50%, don't worry. With that I can take the standard deviation, PQ. And I can compute. Then he has used the formula and given that. So here two things are very important in this story. Sample size can be determined. What is important? First one, your confidence level. Second one, tolerable error. Third one, variability of that character. Variability of that character. These three are required. The first one is tolerable error, second one is confidence level. These two are to be fixed. Once we fix this, quickly I will go because of my time. We know that if nothing is known by central limit theorem, we go ahead with that. Every variable cover under normal distribution if the sample size is large. Statistical regularity again come under. So without prejudice that using the central limit theorem, all variables if the sample size is large, standardization will go, and according to standardization they follow say normal, that is x bar minus mu by sigma follows n0 1. So accordingly you have Z scores. I am not giving emphasis on that because if we go on discussing each and every part, it is not just 1 hour, we cannot cover that. So then the formula is this. With the level of significance, level of confidence interval, 90% confidence interval, 10% your alpha. 95%, 5% is your alpha. 99%, 1%, you have decided. Then normal area tables will provide you those values. Normal area tables will provide you those values. Use that Z score. Once you use the Z score, the formula is this. Necessary sample size is equal to Z score whole square into standard deviation into 1 minus standard deviation by margin error square. If you use this formula, you will get the optimal sample size which will be minimizing your desired levels of error. Desired, that is the minimum required sample size. So this is the formula. We take care about it. If it is proportions, already I told, like an anthropologist, P. P is the proportion. If it is known, put that value. If you don't know about it, don't have any earlier studies, take 0.5. P equals to 0.5. Nothing wrong on that. Okay? So P is equals to 0.5 means it maximum sample that is determined is given. So below that only will come always. If P less than that, P varies from that. P into 1 minus P is there, isn't it? So if it is less than that or more than that, it does not matter. If it is 0.5 we have taken, it is already the maximum required sample size is given on that. So this is for proportions. That for variable, non-proportionate, and this part. Then this. This is a small example I have provided on this. Similarly, another BMA calculation. This is another formula that was given. 881 sample size. This is required. And this part, when you are having this. These are the very important. And nowadays, you have a sample size calculator. You have to put alpha value, put your margin error. If you know the variance, put your S value. Or if you don't know the S value, P is required, put P value. If you don't know SRP, use that. P is 0.5 in that. And earlier studies you can use. And recently that instead of S, people are using CV. Instead of S, people are using CV. That is the very recent, last 2 decades only it was started. And these are the tables available with respect to the sample size. And I think my time, Muniswami may be cursed against me. 11:35 is the hour. So quickly I will close in 5 minutes on that. Okay, this is the very important. I told that null hypothesis, there is no difference. But when we take the difference is null, we have an alternative. If I am going to hypothesis, I accept the null hypothesis, no problem. I am told that there is no difference. But if I am going to reject that, if I am going to reject it, what I can do? I have 3 options. In fact, with the decision, equals to, less than, greater than are all my alternatives. Not equals to is another alternative. So there are three alternatives. What are they? Less than the true value, the estimator is less than the true value. Estimate may be greater than the true value. Estimate may be not equal to, I am not bothered about either side. Suppose pollution control, if I take the maximum carbon monoxide concentration, we all know that if it exceeds more than 100 ppm, no surveillance. And there is a standard, golden standard given by Pollution Control Board. It should be less than certain value. Okay? So, what we have to take? It should be always less than that. Always less than. There you will be taking left tile. Whatever value you calculated, it should be always less than. That you know, that is the maxima. That is the maxima. It should not cross over that maxima. You should have less than that. Okay? Electric bulbs, I want to see the guarantee. Lifetime of the electric bulb. Guarantee I want to give. Warranty analysis. The company wants to do the warranty analysis. The lifetime of the electric bulb. So he will give a guarantee of 100 hours, 100 working hours. 100 working hours he wants to give. Then it should be always less than that. Okay? Or more than that. What should be the correct? It should be always more than. Then only it will come into the market. Otherwise your quality controller take that entire consignment as rejected. So it should be greater than. There. So in such case you have other right tile. So you have a left tile, you have a right tile, alternative. Those two tiles are one tile we call either left or right. So one tile test. You are not bothered about left or right. Not equals to, that's all. I want to say the average student satisfaction survey for my class is 90%. I claim. My university want to test it, whether it is 90% or not. So they take the proportion. Number of students, how many are given? 90% or not. So my p-value, p equals to 90. If it is less than or greater than, it does not matter. I claim it is 90 only. Exactly 90 I am claiming. It is less than or greater than, my claim is not correct. My claim I want to have exactly at 90. Or a screw, when we are designing, the length should be so and so. It should be given a specific value. That specific value, either it meets the specific value or not. So that is very important. So there we have two tail. So alternative is very important. Before going that, in case if you are going to reject the null hypothesis, which you are going to accept, that is called alternative hypothesis. You have to decide before going any statistical inference, what is the alternative hypothesis. Not that alternative is decided after completing the test. Beforehand, you have to decide based on your subjectual expertise. Subjectual knowledge is more important rather than just numerical values. We will support the decisions, but subjectively it should be correlated. So, based on your subjectual knowledge, we have to decide whether, yeah.
Not the null hypothesis. What is null is alternative.
No, that is not correct. Why I am telling, there are three options. When out of the three options, they are governed by your condition. Like already I explained, pollution, there is a upper bound. Electric bulb, there is a lower bound. Upper bound, lower bound is specified, is known. In such case, how do you take less than that? Or how do you take greater than that? You cannot go ahead with that part. So it is absolutely important. Alternative must be fixed before going the statistical validation. Any hypothesis, whatever hypothesis, null hypothesis you have written, immediately you have to write against the alternative. Then only it is statistically robust and correct. Otherwise it is not. Once I got a rejection, I say whichever is closer that I can take is not. Because based on that only, your level of confidence will decide. Your alpha. If I take a two tile, alpha by 2 this side, alpha by 2 that side. If I take only one tile, alpha only will remain on the other side. So it changes the entire value of your critical region. Your critical region is changed. Area covered under critical region become half if it is a two tile. Become full, it is one tile. So you have to decide beforehand. That is very important. Another p-value. I will finish that just telling this because this is very, very important. Many people has to use in the computer. Nowadays, every analysis is a press away, a button. If you press a button, immediately you will get a report. But interpretation is more important. Once you enter the data and press a button, you will get a whole report. But that report you have to interpret and you have to correlate with the facts. You have to write it as it is matching with the fact that was there. So in most of the statistical analysis, whatever package you use, they call p-value. What is this p-value? Probability value. P. So what that it goes? P is greater than 0.05, not significant. Significant? Not significant. What is significant? What is not significant? Suppose I have conducted a t-test in regression analysis because every one of you are well aware of regression analysis. So in the regression analysis, very simple, our beta coefficient, isn't it? We do t-test. What is the null hypothesis there? Beta equals to 0. Against the alternative, beta is not equals to 0. That is your t-test you will be performing in your regression analysis when you take the constraints or constant as well as the other coefficients, testing that. Suppose beta, that p-value is 0.01 you got. 5% is your level of significance. 0.01. What you say? It is significant. What is significant? What is significant? Beta value is significant. Beta value is significant. Then what it means? Beta is not equals to 0. That means what you have done? You have rejected the null hypothesis. You have rejected the null hypothesis. You have accepted the alternative. Able to get the point? Because the regression analysis, every one of you is very thorough. That is what p-value is. P-value is less than 0.5, I told 0.505. That is the level of significance. Your alpha, level of significance. You have to decide beforehand. Tell me.
Sir, generally there is a practice there is a practice in when we are using p-value, the significance level that is less than 0.5 or more than 0.5, and we told it is non-significant, it is significant, as you told. But recently I got a No. What I am saying recently, not I have researched many times and fortunately got a article that is Tukur Dahir. He is a medical professor. He wrote what Fisher has started this concept, and he told, according to Fisher, it is like probability. Suppose we are more close to the towards zero, then it is significant, and we are suppose we are coming towards let me speak, I am coming to the one that is less significant. It is not significant. He is saying it is significant, more significant, less significant, but we are practicing it is not significant. Yes, sir.
Well, yeah, not I have my working. My voice is very loud.
Very loud.
Because I used to take class. Trainers. So, what is actually Fisher's consideration? What is it? Alternative. None. So when you are taking that, what 0.1, 0.1, whatever it is. The confidence, what we talk about, of significance. My 1 minus alpha. Level of significance. When you are talking about the probability of committing type 1 error. Committing it is less significant or more significant, whatever it is, you have only two alternatives. You have only two alternatives in your decision. Entire statistical test goes with two alternatives only, isn't it? So, what is the alternative? First one is null hypothesis. Second alternative is rejecting the null hypothesis. Okay? So, here less significant, more significant. Because it is a probability, whether you talk about less significant or more significant, it does not matter me. It matters only whether my null hypothesis is accepted, rejected. Null hypothesis is accepted or rejected. So as a statistical sense, I say I will accept H naught. I will reject H naught. But for the others to make more and more rigorously drive towards the statistical analysis, if I say null hypothesis is accepted, okay, it may not be taken by other discipline people so easily. So I can say the difference is significant. The difference is not significant. If I say less significant, then he will put a question. What is the very significant? If I say it is more significant, what is the very significant? It depends on your level of confidence. When I say it is your level of confidence, again I have to go back, critical region, isn't it? So here big question comes, particularly in medical science. 40% is also an acceptable level. Do you know? Do you know that 40%? No statistician agree. But in biostatistics, morbidity when we take with respect to the disease burden, 40% is also acceptable. We take that. Level of significance is 40%. Surprise to the statisticians. But 40% is a regular phenomenon. Even if why they say that is, if it is more than 50%, okay, they can be able to take seriousness. The seriousness is more important because the burden, this is burden. This is burden when they analyze. Even 40%, no statistician, no social science survey will go beyond 10%. Confidence, level of significance. But in biostatistics, I will show you the textbooks itself given by many of the very, very prominent researchers. Even 40% they say it is acceptable. Why? Because their importance with respect to the subjectual knowledge. That is, okay? So this is the very important p-value. One has to interpret properly of this. So in fact, I want to talk about all these tests and other things. If time, unfortunately, I have to lose 20 minutes in the beginning itself. Some of my friends has taken 3-4 minutes to introduce myself only. It is a waste of time, in fact. And my profile is available in the website. I told Muniswamy even. Those who are interested, you can send one sentence available in the website. Yeah. Yeah.
What you do? Chance.
Which one? I could not understand.
Sorry. Do generally biostat.
Yeah.
Suppose you run or you use a model logistic regression.
Yeah.
Generally, we biostat use logistic regression. And what you found, this group has more chance or more likelihood compared to the other group.
Yeah. In fact, let me tell you, without taking most of this, I will tell you. What exactly is probit analysis you have to do there. Most of the things you have to do probit analysis. When you go for probit analysis, particularly in biostatistics, that is the peculiarity of the biostatistics that comes into in the biostatistics, probability analysis is log likelihood functions are calculated. Log likelihood. Okay? So your p-value does not come into the most of the thing, except your testing part of it comes. Where it takes, it is the specific case of the considerations that was taken. For example, in biostatistics, if you take the not only the particular disease burden, if you take the, for example, viral markings, that is your golden marking, sorry. Golden markings, when you want to design that, even if your p-value, okay, there less significant or more significant is not considered. Wherever you talk about less significant or more significant, it is a confusion. It prevails confusion. I say it is less significant. I am not taking a decision. Decision is very clear. That's why they have used this as significant, not significant. That is the part what it comes. Okay? This, in fact, I taught biostatistics for more than 4 years for our biotechnology people. Lost in that, I have few works on medical statistics also. I designed, in fact, a model for multiple sclerosis disease, which was a very, very rare disease. I worked with the doctors, and we had a very big project on that. Multiple sclerosis, a rare disease burden, which can be cured, which affects the nervous system. Entire nervous system get paralyzed on that. We published that paper in medical journal, Asian Journal of Medical Sciences. That we have published that. Okay, and coming to this, quickly I will go to, I want to, in fact, if I have a lot of time, I want to show you some SPSS package workings also. This. So, but statistics is a very important subject. Statistical analysis, it is like, before I conclude, I can tell you only one thing. It is like a medicine. If properly utilized, it helps the people to take right decisions at right time. It is wrongly used, it kills the entire processes and procedures. So it is like a medicine. One should be very careful when you are doing your statistical analysis. I thank Muniswamy and also Dr. Sundaram for giving me an opportunity to interact. My email ID is given in my PPTs. I am leaving the PPTs. You can go through the PPTs, those who are interested. No doubt on that. It is only a PPT. If you want to add something and you want to present or you want to share something with somebody else, I have no objection. It is, I have taken care on this. So you can use these PPTs, go through it. If you have any doubts on that specifically, my email ID is given in the PPT. You can give it. I may not respond in 24 hours, but I will definitely respond in 72 hours. Because some of the foreign, my guru is there, C.R. Rao. You may be knowing that legendary statistician who got the International Prize of Statistics. I have very close association with him. And he gives me a mail. If I don't respond within 24 hours, he puts me another mail. Are you lazy or busy? Before I respond back. So that's why I'm very cautious about, I will respond within 72 hours, no doubt on that. So thank you for this. Yeah.
Time I found the details is only for less number of variable, less than 30, but
Yeah.
I found in various websites, international journals, some people are using t-test more than 30 observations.
Yeah.
What is your comment, sir, on it?
More than?
More than 30 observations.
Yeah. Here, what exactly the sample size? Large samples and small samples. We have theory, entire theory goes by 2. Large sample theory, small sample theory. So when we go for this, what is a large, what is small? How do you decide? There, in fact, the great statistician Tippett has done an empirical study with respect to normal distribution. Okay? He has taken the samples, different sizes. When the sample sizes are increased, the standardization with respect to, for unimodality, statistical regularity is only unimodal distributions I am talking about. Multimodal means it is a mixture, no doubt on that. So when we take unimodal distributions, he started our working. When he is working after 30, it become large. Large, the standardized variate. Standardization means x bar minus mu by sigma. X bar minus mu means mean, sigma means standard deviation. X bar minus mean by standard deviation. That stabilizes to follow normal distribution. That stabilizes after 30. So he has taken large number of samples. At that time, no computers were there in 1800. So at that time, he started off working with his facet machines. Facet machines, maybe some of the elderly people may be knowing that. When I was doing my practicals, I done my practicals only on a facet machine, not on a calculator. We don't have calculators at that time. We have to do a big electrical machine to calculate the calculations, and manual machine, a facet machine, where we have to put like turning this, all the numbers quickly, so that it will give a alarm once the answer is came out. If you go one more round, the answer go wrong. So our practicals were done on that part. So he has done taking all the pains. 30 is a stabilized. So after that, whenever you take more than 30, the standardized variable under regularity conditions follows a normal distribution. That's why they tell below 30 is a small sample. You have to take exact distribution. Above 30 is a large sample. You can follow normal distribution where you can take. That is the rationale. Yeah, that is the rationale. All this was written in Harold Kramer's book. Mathematical Statistics by Harold Kramer. It is Veda of statistics. Okay? Thank you. I thank all the participants for your patient listening. I thank Dr. Sundaram and his team for giving me an opportunity, and my good friend, very dynamic head of the department we have, Muniswamy, for the given opportunity to interact. Thank you.
Okay, thank you, sir, for your elaborate lecture, right, delivered on sampling techniques and also as well as testing of hypothesis, right? So, sir has vast experience in data collection, right, as well as in the research. So he published he completed more than 50 PhDs he given to our 58 is completed. Not only, yeah, not only in the Department of Statistics, he worked with the computer science, mechanical engineering, right, management, commerce, right, in all the disciplines he covered. So thank you, sir, for accepting our invitation. Just 4 days back, right, I requested, sir. So in spite of his busy schedule, actually we have another program university is conducting. So he given more importance to academic. There is only sir present, but here this is academic. So always he is giving preference to the academic. So thank you very much, sir. Thank you for giving the lecture. Thank you, sir.
Thank you.
Now we have a tea break. So we will be assembled by 12:20. Yes, ma'am. 20 minutes break. Okay. We'll be available, assembled by 12:15. 15 minutes tea break. Next. hands-on experience. But before that, practical session, he wanted to explain in a theoretical manner. So now I would like to invite Professor B. Muniswami Garu. And before that, just I request Srinu Setti to brief introduce about Professor B. Muniswami Garu.
I am honored and privileged to introduce Professor B. Muniswamy, Head of Department of Statistics and Honorary Director, PRC, Andhra University, Visakhapatnam. Professor is specialized in stochastic models, econometrics, statistical inference, biostatistics, and statistical computing. Professor B. Muniswamy has 15 years of teaching experience. He has published 45 papers, national and international. He has conducted 31 research studies. Professor has presented 24 seminar papers, national and international. He has attended 24 national and international workshops. Professor has delivered 42 guest lectures within and outside the university. He has guided 6 PhDs and 3 are ongoing. Professor has organized 8 training programs and workshops. He also organized 3 webinars. Professor B. Muniswamy has received first prize and a cash award of rupees 1 lakh as a head Department of Statistics towards best performance in NAC third cycle peer visit in 2016. Professor has received Best Research Award in IJI EMR Elsewhere SSRN Research Award through International Journal for Innovative Engineering and Management Research Elsewhere SSRN in 2021. Professor has served in the university as the nodal officer from he is also serving as chief warden on the university research scholars hostels. He served as chairman PG Board of Studies, deputy coordinator UG SAP DRS1, co-convener, AU Research Forum committee member, Central Pursuing Committee member, College hostels. Professor was a principal investigator for major research of the adolescents in ITDA residential schools of Visakhapatnam district funding agencies, UNICIF 2019. Thank you.
Now I request Professor B. Muniswami Garu, please come and take your session, sir. Thank you.
Thank you, Srinivas. First of all, I would like to say thank to the ministry for organizing this 2-day workshop. And also I am participating to deliver a lecture on measurement and scaling techniques, right? So whenever we prepare a questionnaire or schedule, right? So before going to the field or before preparing the questionnaire or a schedule, we should know what are the measurements and scaling techniques, right? So generally in any investigation, we are formulating variables and factors, right? So our statistical applications are different from variable type to type, right? So generally the factors are influenced on the variables. So we have to identify exact factors. Some factors are not influencing, right? Some variables is also not significant. But how can we recognize? How can we identify which variables are influencing and which variables are not influencing, right? So all numbers are not a statistical numbers. Few numbers, we call it as a statistical numbers. For example, you see the importance of numbers. Suppose 0.8, 0.9, minus 0.6. So these are all what? Just a fractional numbers, right? So it won't give any meaning. Suppose in a statistical number, suppose you see the correlation value is 0.8. Correlation value is 0.8. Right? So degree of positive, right? So degree of positive, right? So degree in the sense, if the correlation is there, if the relationship is there, how much relation? Speaks to you. So numbers speaks to you. Statistical numbers speaks to you. So once at present, need not to memorize dozens of formulas in our mind. We have a wonderful statistical packages and programming languages like statistical packages, SPSS, Statistica, Swisstat, Minitab, right? So many are there. But in the programming languages, SAS, R. Nowadays, R is popular and powerful. Why? It is a open source. It is a open source. Right? Anyone can download a open source. Right? Compared to the SPSS and R, generally which one is better? SPSS is better or R? R is programming language. SPSS is menu driven program. Just select and click environment. Select and click environment. Using SPSS, what are the variables and what are the factors? How to analyze? So SPSS have one separate SPSS readable formats. In that readable formats only we have to enter the data, right? So in any investigation, right? So we are taking like this. You see the performance. A performance of a lecture, performance of a customers, whatever it is, I want to measure right? The performance is taken here, only 4-point scales, right? So these performance, some investigators, they are taking only 2-point scale, satisfied and not satisfied. Yes, sir, no. Okay, some investigators, they are taking satisfied, not satisfied, but sometimes they can't say whether it is satisfied or not satisfied. So it is depending on degree of your agreement, degree of your investigation, right? So some investigators are taking 5-point scale. Okay, so it is depending on sensitivity of the question. So this is suppose teacher performance evaluation, right? It's depending on what type of variables I have to include it, what type of factors I have to include it. So first and foremost, as a data analyst, we have to identify observations, variables and factors. If I identify the variable, how many types of variables are there? Generally, to analyze the data, four types of variables: nominal, ordinal, interval and ratio. So according in the SPSS itself, if you want to analyze the data, it asks what type of data you are going to analyze, right? So this is, so in this case, first to identify, suppose in this data you see, this is regarding to management data, is there any numbers? No. Okay, so we can analyze, right? So in this table, how many variables and how many factors are there? Anyone? Just these are my classes, entire classes are interaction like. Okay, so how many variables and how many factors? 2 variables, 4 factors. What are 2? Factors? No, no, no. Yeah, sorry saying. 1 factor, 3? Yeah. Right? So sorry saying, right? Okay. So first and foremost, what is a variable? Variable means it possesses one characteristic. It possesses any one characteristic is a variable, but factor is influenced on the variable, right? For example, you see in this case, gender is a factor. Gender is a factor. So the brand A, brand B, brand C is a variables. Okay, so suppose the selection of brand, the customers or participants, whatever it is, the selection of brands is depending on, is there any gender effect? Here what? Gender is factor. Okay, so how this factor is influenced on the selection of brand? Okay, so generally, which type of statistical analysis we are performing? Okay, so gender is what? Variables are not a measure. Gender is, variables are not a measure. It is a labels, male and female. So its type is nominal. Its type is nominal. But whereas you see brand A, brand B, brand C, how its variable values? Good, excellent, worst. These variable values are what? Have some preference. It is an ordinal. The variable values are ordinal data types. Okay, so nominal by ordinal. Variable types are nominal by ordinal. So which type of statistical analysis? Okay, so in this case, you go for inferential statistics. It is a chi-square test. Both variable types are nominal. You can apply chi-square test. One is nominal by ordinal. Also, we go for chi-square test. Okay, so this is the how to identify. Just I will show some case studies. After not direct, we go for hands-on experience. Right. So now, so here, 2 types of exercises are there. I want to collect heartbeat pulse rates. right? 100 members are gym exercise, 100 members are yoga. Which one is better? Either yoga or gym. Suppose I ask to you which one is better. What is your opinion, sir? Right? So at present nowadays yoga is famous. Right? Recently we celebrated International Yoga Day. Modi ji is also did yoga. So anybody asked you, but as a statistician, we don't believe name, fame and history. We don't believe name, fame and history. What we believe? We believe only the data. Next. Babu, so we believe this data, right? So now can you say that which one is better? Just to see the data, can you say? Isn't it? It is not possible. So we can apply a simple statistics. We can apply a simple statistics. That simple statistics is a descriptive statistics. It covers measure of central tendency, measure of dispersion, measure of shapes, right? So in this lecture, in this slide, how many variables and how many factors are there? So this is yeah, one factor and three variables. Okay, so is there any gender impact on the type of exercises? The values are control group means without exercise, person's data you collect it, right? So group B is those who are doing gym exercise, you collect the heartbeat pulse rate. Those who are doing yoga exercise. Suppose there is no gender, just you take what is the analysis. Is there any significance difference between the heartbeat pulse rate of these three types of exercises? Which one is better? You have to suggest. Okay, so that is type of analysis. A simple basic text is not support. So we go for inferential statistics. That is ANOVA. You know that. ANOVA means analysis of variance technique. The technique is used to test two or more than two sample means. Right? So variable values, which type? Isn't it? The first one is nominal, gender, right? So grade, group A, group B, group C, the variables values are interval data. Variable values are interval data. So interval in the sense again it's classified into two groups. One is discrete, another one is continuous. Okay. So here discrete in the sense single values. Right, like 67 centimeter like that. So continuous in the sense it's have a two limits interval. So the heartbeat pulse rate is 68 to 76. This is a continuous type of data. So for this type of data, which type of statistical analysis we are going to apply? Okay, right. So this is a food and nutrition department in our university, right? They gathered the data. Okay, so they prepared one drink. They prepared one energy drink, right? So that drink supplied to these five types of sports persons, right? And also they classified as males and females. Okay, so if those who consumed the drink, right, that drink produces this variables. You see, right? Here the variables are energy, protein, fat, CHO, cholesterol, iron, vitamin, like that. So in this slide, how many variables and how many factors are there? Hmm. 8 variables. three factors are there, right? One is what? Sports type. Okay. The second one is gender, male or female. Only three factors are there. So they given a data to me, I analyze it and I give it to the researcher. The food and nutrition department, they said, sir, your entire analysis was wrong. Our theory says one direction, but your analysis says another direction. Right? But I observed, right, what is wrong with me. Okay, so here, for analyzing the data, some factors influence is missed. One factor influence is missed. What is that factor? Right? This is the sports data. Okay, so age is missed. Right? Generally, suppose you take the energy. If those who consumed the drink, it produces energy. Okay, the energy is also depending on age. Okay, so under 11 years, under 15 years, under 21 years. So what they did here, they missed the properties of a variable. They mixed the properties of a variable. They mixed up all the age group, people under one category. So anybody data given to you, first and foremost, we have to test whether the variable is homogeneous or not. The variable is homogeneous or not. So I told that you have to classify data according to your age. Then only your results may give good result. So we have to identify variables, factors, and also we have to test the properties of a variables. Right? Right. But these are all only I am showing the case studies. Right. So here, how many factors and variables are there? Just to see, the first one is a factor. This is what? Grade. But how the grade values? Mild, moderate, severe. That means which type of variable it is? Yeah, it is ordinal. But the second one, right, it is a nominal. But the third one, it is also a, this is also a nominal. But this is tail length interval data. Right? Interval data, but it is discrete data. Then age is also interval, but it's discrete data. Right? So I am skipping this. These are all only the data sets, different data sets. But what type of statistical analysis it's required? Okay, we can discuss. So this is also just only the different types of data sets. This is contingency tables. For this type of data, which statistical tests we are going to perform? Okay, so if the observations of frequencies, we go for, suppose which test here you see, to own the position, is there any gender impact on the position? Which test we are going to apply? Right, go for chi-square test. Right? Right. So here you see, these are all simply data. Now I am going to measurement and scaling techniques, right? So measurement means we can assign numbers to a particular characteristic. We can assign numbers to a particular characteristic. For example, gender is there, but SPSS, better to enter the data in a form of a numbers. We can give a coding, right? Coding number. So that coding may be a symbols or numbers, but generally the numbers is preferable in the measurement and scaling technique, right? So there are mainly 4 measurement and scaling techniques, right? The first one is nominal. Okay, so in this nominal means variable values are labels. Variable values are labels are names. For example, gender, right? Area, urban or rural. So satisfaction level, satisfied or not satisfied. So in this nominal case, what type of statistical applications we can perform for nominal case? ఇది పెట్టు. For nominal case, what type of statistics? So only it is count data, count purpose, then you can apply percentages for nominal data, and also then we can apply for inferential statistics. We go for chi-square test. We go for chi-square test. So these tests we are applying. But for nominal case, it is not possible to apply logical and arithmetical operations. It is not possible to apply logical and arithmetical operations. For example, in this case, what is average gender in this class? How we measure average gender? May I take male plus female divided by total number of participants? Isn't it? So it's not correct. So that's why what here we are not applying plus addition minus like that. So which type of statistical applications we can take it? Average gender, you go for mode. For nominal data, if you want to apply descriptive statistics, you go for mode. Mode means what? Most frequent value. So which category is repeated more number of times? Okay, that is a modal value of this variable. So here in the descriptive statistics we are applying mode. If it is a inferential statistics, two variables if you want to study, we go for chi-square test. So in the case of nominal ordinal, we are not using arithmetic and logical operators, right? So whereas in ordinal data, just to see the image, right? So ordinal, hot, hotter and hottest. So here what? Has some preferences. So that is hot is less than hotter, hotter is less than hottest. That means what we are applying here? Logical operators. So here the variable values is what? Okay, suppose you satisfied or not one particular product, you say that excellent, someone says that good, someone says that poor. Okay, so this type of variable categories comes under ordinal scale. So in this ordinal scale, we can apply for logical operators, right? So logical operators already we know that it is what? Less than, greater than, equal to, and or. Okay, these operators we are applying for ordinal data but not nominal. Okay, but in the case of ordinal data, it is not, we are not using arithmetical operators. We are not using arithmetical operators. Arithmetic operators means it's a simple addition, subtraction, multiplication, division. These operators are not applying for ordinal data. We can apply only logical operators, less than, greater than, more than and or. So, but whereas in interval scale, so interval scale means direct value. Suppose your age is 20, your age is 20, say 20, 21, 65, direct it is interval scale. This is a discrete. Continuous data is there also there. Age is lies between 20 to 25, 25 to 30. That type of data we call it as continuous. So in this interval data, we can apply both logical and arithmetical operators. Logical and arithmetical operators. So as far as descriptive statistics concerned, nominal we go for only mode. In the case of ordinal data, you go for median, right? Arrange the data in a systematic order, right? From left to right or right to left, either increase or decrease. We take it a median, but interval data, you can apply all permissible statistical applications, either mean, median, mode and geometric mean and harmonic. Yeah, that's why I will explain in the analysis part, sir. In afternoon, I will explain. This is only theoretical part. We'll cover. Afternoon, we can expect, right? Yeah, thank you, sir. So this is in the interval scale. We can apply. You can calculate mean, median, mode, geometric mean, and harmonic mean. So ratio scale is also like that. So ratio scale in the sense, for example, out of 6 feet, what is your height? Okay, so out of 100 marks, what is your marks? So out of 24 hours, how many hours we're spending with our smartphone? So that type of data, we go for, okay, ratio type of data, right? So this is just, but how to analyze this? Is there any numbers? Isn't it? There is no numbers. For example, you see the color, how many colors are there? Isn't it? Blue, red, green, yellow, then orange. So the analysis is how many blue balls are there? It is, we call it as a variable frequency. The frequency. How many blue balls are there? 4. How many red? 3. The rest are 1. The total is 10. Isn't it? So you see, this is a qualitative data. You convert it into a tabular form, right? So the frequencies, then you can calculate a percentage, right? So the percentage is, this is 40 percentage, this is 30, 10, 10, 10. The total is 100. Okay, suppose if this is only frequency table, it's called it as, right? Suppose if you want to calculate what is the model color of this, what is an average color model, right? The model is which category is repeated more number of times? Blue. Suppose customers are visiting in this shop, the selection of customers, the average is blue. Here we call it as an average. Average is actually, what is an average? The definition, people are generally thought that average means mean only the average, right? So average means, average is a single value. That single value represents the significance of the whole data. That averages are mean, median, mode, geometric mean, and harmonic mean. These 5 we call it as simply average, right? But these 5 is depending on type of a variable. Okay, so here we take the mode is blue, right? So is it possible to take an average of this? Can I take 40 plus 10 plus 30 plus 10 plus 10 plus 10 divided by, isn't it, 5? Okay, is it good? So that's why what I told to you, in the nominal case, it is not possible to apply arithmetic and logical operators, right? So this is simply a nominal data. If you want to apply discrete statistics, this is average is mode, right? So I am skipping this. Generally, nominal means males or female. So you see the first point, nominal case, no order or distant relationship is taken, right? That means arithmetic logical operators are not using. No arithmetic origin, only count numbers in categories. This count numbers in categories. The next one is only present percentages of categories. Right, next, chi-square, most of used to test statistical significance. Okay, so these analyses are performing for nominal data. Right. So other examples is also there. Right. So next, ordinal data. So ordinal data we can apply, you see, can include opinion and preference scales. We can take a scale questionnaire, right? You satisfied or not satisfied or can't say. Some person may take agree, disagree, not disagree for that type of data. So here we can take median but not mean. Okay. Why not mean means we are not applying arithmetical operations, right? Only logical operators here we are taking. So no unique arithmetic origin. So items cannot be added, right? So we use this. So this is interval scale. Next ratio scale, ratio type of data, right? So ratio scale, right, includes actual amount of variable, okay, shows magnitude of differences between points on scale. So all statistical texts, you can apply mean, median, mode, geometric mean and harmonic mean. We can apply this. So simply we call it as, suppose you see, right? Suppose in the race, supposed to finish 20 seconds, right? First one is taken 10 seconds, so it's taken as 15, this is 20. So out of 20, what are its portions, right? So out of 7 feet, what is this image feet and this image feet? So this is this type of data, we call it as ratio scales, right? So all 4 measures, just you see in this slide. So nominal means numbers assigned to suppose runners. So behind their t-shirts, the numbers are there 4, 81, 9. So may I say that 81 is greater than 4? No, but we it's a numbers. But these numbers are only pure labels. Only pure labels, right? There is no permission for calculation of statistical tools, right? So in the case of same images, you see for ordinal rank order of winners, you see he got third place, second place and first place. Here ordinal data is there. So you can apply only, you see third is less than second, second is less than first. Okay, logical operators. So the interval data means, you see, performance rating on a 0 to 10 point scale, right? Performance. The first person, its performance is 8.2, 9.1, 9.6. You can take the average performance of these three. You can take average performance. You can apply arithmetical operations, right? All the values addition divided by 3. Okay, so you can take the average. So ratio is also, suppose time to finish in 20 seconds. First person is taken as 15.2 by 20, 14.1 by 20, 13.4 by 20. Here is also we can apply arithmetic and logical operators, right? So now for nominal type of data, right, we are giving only labeling purpose, what type of statistics we can apply. Okay, so then I'm limited applications I'm giving for the space constraint. Okay, so in the case of ordinal scale, right, so you see, next interval scale, then ratio scale. These are all some how the statistical tools we can apply for types of a variable. Next again, these types of variables, again the statistics is classified into 2 categories, 2 types. One is descriptive statistics, the other one is inferential statistics. Okay, so what about the statistical applications for these 4? See, first column is scales. Nominal, you go for descriptive statistics, percentage mode, inferential statistics, right? Chi-square. So when we apply the binomial test, suppose you visited to the bank where their services are satisfied or not satisfied. At that time, you go for inferential statistics, binomial test. Okay. So this is rank order, percentage, median. So these are all descriptive and inferential statistics. Right. So the variables are classified into and categorical. So our statistical applications are different from variable type to variable type. So in the case of numerical, we go for continuous and discrete, like this is interval data. Okay, then ratio data. So this is ordinal and nominals or the categorical data, right? So now you classify first group variables in which type of a variable, either ordinal, nominal, interval or ratio. The first group, can you identify? Yeah, this is which type of variables? Hmm? So second one, nominal. Third one, ordinal. Right? Why means this is helps to prepare a questionnaire and schedule. Okay. So before in your mind, I am applying ordinal data. What type of statistics you can estimate, right? Expect. Okay. So that's why before going to the field, first in advance also we can decide a statistical tools and techniques. Suppose I am going to apply, right, multivariate analysis techniques, but your questionnaire is not supporting. But I have a knowledge on multivariate analysis, but which type of variables I have to include. So in advance we have to decide, right? So this is, so the last one you identify first one and last one. Okay. Yeah, ratio and interval is there. So the first one is interval, the second one is nominal, the third one is ordinal, ratio. But almost interval and ratio same. Applications is also same. We are applying. So this is the variables, right? So what is a variable properties, right? So see the image, right? So this is variable 1 x1, this is variable 2 x2. May I conduct competition between these two variables? In a statistical sense, we think what is that? Think as a variables, right? So it is not. Why? The properties are not satisfying. Okay, so generally people are directly goes to the field and gather whatever the data is there. We are gathering, right, irrespective of any properties, right? So simply you see, may I calculate average age of in this class, right? In this workshop, may I calculate average age? Yes, right. How we calculate? Your age plus your age plus your age, right? So, sir, excuse me, may I know your age? 60, right? So your age, sir? 56, 47, 46, sir? 56, 47, 46. Sir, yours, sir? 43. Yours, madam? 28, 38, 27, 36, 42. Isn't it? So may I calculate average age of this group? Simply enter the Excel, then you apply average, it gives you. But suppose the average age is 45.6. Is it right? Isn't it? So it gives a wrong. 45, why means one age is 60, one age is 20 plus, one age is 30. But you are saying that on an average, isn't it? The number is 45.6. Isn't it? That's why we have to apply before going to statistical tools and techniques, right? So we have to apply the properties of a variable, that is a line property. Linearity, independency, normality, and okay. So independence in the sense variable values should be independent. The observations are not depending on other observation values. Suppose age, your age is not depending on others, we know that. Sometimes, suppose heartbeat pulse rate. The heartbeat pulse rate may depending on some situations. Okay, so that type of variable values, what type of statistical applications we can take it. Okay, so independency, but that is a independency. Linearity in the sense, first you collect whatever the collected data, first you draw a line diagram. The line should be approximately a straight line. Approximately a straight line. That is to testing of a linearity. Suppose our age is 60, my age is 50, one age is 22. The line is very up and down. So for that type of data, it is not suitable for some statistical applications. So we have to trimming the data. So that is a linearity. Independence I already told to you. The observation should not independent. The simple example is suppose the percentage of marks. Percentage of marks. Suppose I conducted one test, my marks is 60. How I got the 60? Is it my talent or is it my intelligence only? Isn't it? Suppose in a classroom, exam is going on, what is the need of invigilator? What is the need of invigilator? Right? We don't allow the mass copying. Why? You observe whether your mark should be yourself, you have to get it. Suppose you are depending on the others, it is not IQ of your levels. So that's why we are keeping one invigilator in the classroom. Is you should not violate the property. Okay, that is independency. Next, normality. Error terms follows normal. Then equality of variances. Well, we are applying the t test, f test, ANOVA. We assume that the variances are equal. The variances are equal. Suppose in one particular class, suppose standard 10th class, right? All students IQ levels are same. Right? In the classroom, all IQ levels are same. Are you sure that? Isn't it? IQ levels are different. Okay. But why we give same question paper? We know that IQ levels are different, but why we give same question paper? Isn't it? So we assume that each and every student's IQ levels are equal. So while you are applying statistical tools and techniques, two assumptions are there. Equal variance is assumed and unequal variance is assumed. In the Microsoft Excel, while you are carrying a t-test, right, it asks to you before whether the variances is equal or variances is not equal. So these four properties are using before analysis. Right. Right. After identifying variable types, nominal, ordinal, interval, ratio, next you have to identify whether the variable is independent variable and dependent variable. So our statistical tests is also different from this. Suppose one is independent, another one is dependent. Both are independent, both are dependent. Which type of statistical analysis? Suppose both are independent. Right? So heartbeat pulse rate males and heartbeat pulse rate females. So which test you are going to apply? Is there any significance difference between the heartbeat pulse rate of males and females? Both are independent variables. Which test? A simple test. Isn't it? So two regions are there, North India, South India. The heartbeat pulse rates are same or different? I want to know. Which test? Simply, generally people are taking mean and variances. So it won't give full information. Simply we go for t-test. T-test. So t-test is used to test two sample means only. Two sample means again here you are using interval data. So if you want to apply t-test, suppose one variable is gender, another variable is heartbeat pulse rate. May I apply t-test? No. Both variables should be interval type data. Then only you can apply. That way, two variables should be independent. So interval, independent, then the application purpose is to test the means. Okay? This is, suppose one is independent, another one is dependent. Which test we are performing? We know that, no chi-square. One is independent, another one is dependent. Variables are interval data. Variable type is interval data. One is independent variable, another one is dependent variable, like price and demand. Heartbeat, pulse rate and age. Isn't it? So we go for correlation and regression analysis. Compulsory, one is independent, another one is dependent. Both variables are interval data. Then we go for correlation and regression analysis. Okay, so these are all, it's depending on type of a variable, whether it is independent or dependent. If three independent variables are there, more than two independent variables, their values are interval data. Which test we are going to perform? Yes, good. Which is, sir? ANOVA. Analysis of variance test. The test it is used to test more than two sample means. It is an extension of t-test. It is an extension of t-test. So simply we are using ANOVA, right? So whatever we are doing, I am closely observing. I participated also several workshops who conducted Ministry of Statistics Division. So generally people are using only percentages, isn't it? Graphs, almost using ANOVA, correlation, regression. But we have a lot of statistical tools and techniques are there. Now, multivariate analysis techniques. Multivariate analysis techniques. Cluster and classification, discriminant analysis, factor analysis, right? So these are all at present very simple. Once upon a time it is difficult. Why? We have wonderful statistical packages. Just only if you know what are the variables, factors and SPSS readable format. SPSS readable format. Just it is a select and click environment. Within a fraction of second, the output is applied, right? Display in your screen. But the thing is how to interpret. How to interpretation, right? So this interpretation, but how to take a decision, which type of data, which type of statistical tools we have to apply. All tools are available in SPSS, but how can we select? Okay. So it is depending on the base is measurement and scaling techniques, whether nominal, ordinal, interval, ratio or independent and dependent variables. Then we select statistical tools and techniques, right? So time is what time, sir?
118.
118.
Sir, can you guide something on what is sampling distribution?
Sampling distribution. So it is standard deviation of the sampling error. Standard deviation of the sampling error. So we are applying standard distribution.
Like we are doing T.
Yeah.
T itself is a statistics.
Yes, sir.
Must be following some distribution.
Yes, sir. T distribution. Separate T distribution is also there. T distribution, F distribution. All it's again it's a property goes to the normal. Compulsory.
Asymptotic.
Yeah. Asymptotically normal distribution. Right. So afternoon we can discuss directly hands-on experience. I will cover descriptive statistics and inferential statistics. In the inferential statistics, correlation, regression, T, F, chi-square, then analysis of variant tests. These tests I will cover. Right. Okay. Continue and I'll continue. Yeah, when is it any time? That's why I'm reading. Oh, Anand, slideshow. And when is it any time? That's why Anand, slideshow.
आप आगे बढ़ते हैं
Come, sir.
क्वेश्चन पूछने वाला इंसान लोग कौन
All here. Sit here.
Suppose
Yeah.
these types of situation is occurred suddenly. Suppose before we have not think that as the distribution is different. Someone is 55 years, some is 20 years or 35 years. And okay, it is. So linearity is not present.
Yes, sir.
For its purpose, I think, sir, before you have explained that mode value is helping us.
Yes, sir. Mode.
Mode value.
Mode.
Mode value is
Yes.
help us to analyze the data. Some situation is I actually come forward that the linearity is not found. Like this our assemble here.
Yes, sir.
So mode value is I think that this will help us to find out whether it is have same linear
Yes, sir.
as group.
Non-linear models we can apply, sir. Non-linear models. So in the Excel, I will explain. I take one regression model. If one, at least you can change one value, it affects a lot in the model. Simple one variable value affects.
Again, say something about the Z test, difference between T test and Z.
Yes, sir. Right. So SAR is asking what is the difference between Z test and T test, right? So T test is a small sample test. Morning we discussed in the class. So if the sample size is less than Gen 3 is statistical value, calculated value, we are comparing with to the tabulated value, right? So the tabulated values are depending on size of the samples, right? Whereas the Z test is fixed, more than 30 sample, right? If it is a 5%, 1.96. So calculated value, table values are fixed. But whereas in SPSS package, any other you see, there is no Z test.
Yes, Excel.
Right? There, your question is that there is no Z test. Why? In the sense, small sample test is applicable to the large sample test, but large sample test is not applicable to the small sample test. So that's why instead of Z test, generally we are using T test.
That's why we found some first.
Yes, sir.
Large sample set also T test.
T test. Suppose in the SPSS also you can't find Z test. This is reasons.
Sir, please continue. Sir.
Yeah. Madam is. What, sir? May I continue or? Yeah, it's completed. Why? After lunch, I will focus on more hands-on experience. This is the theory.
Something left for a theoretical part.
The theoretical part is okay, completed, sir.
Then we can start after that.
Okay, sir.
There is very technical item is there in the
Yeah, that's why, sir. Okay, thank you. Thank you, sir.
Thank you very much, sir. You have explained in elaborate manner regarding statistics hands-on experience. We are very much thankful to you, sir. Now it's time to organize a valedictory session. Now I request Asha to start the program.
A very pleasant good afternoon to all of you. Now it is a time to conduct validity session. In this reward, first I would like to invite Madam Miss Anjali Reward, Deputy Director General Statistics, Ministry of Health and Family Welfare, Government of India. Yes. Next, I would request to invite Sir Kumarasundaram Sir, Director of Statistics, Ministry of Health and Welfare Family, Government of India. Next, I would invite Madam Miss Preeti Tiwari, Assistant Director Statistics, Ministry of Health and Family Welfare, Government of India. Next, I would like to invite Professor B. Muniswamy Sir, Honorary Director of Population Research Center, Andhra University. Thank you.
Thank you, madam. Thank you, sir. So now I would like to invite all the PRC participants one by one. So kindly issue memento as well as certificate with your hands. So first I invite Mr. Deepak Das, Field Investigator from PRC Guwahati. Next, Mr. Karuna Gogoi, Field Investigator, Guwahati. Please come fast. And next, Mr. Krishna Raj, Research Fellow, PRC, Patna. Next, Dr. Neep Narayan Lal, Research Investigator, PRC, Patna. Next, B. Sajita V. Vishwan, Field Investigator, PRC, Kerala. Dr. Sajita B. Data Assistant, PRC, Kerala. Dr. N. Kavita, Chief, PRC, Gandhigram. Dr. M. Senthil Kumar, Field Investigator, PRC, Gandhigram. Kavita, ma'am. Next, Dr. Vinay Sivanandan, Assistant Professor, PRC, Pune. Dr. Ravi D. Prasad, Research Investigator, PRC, Pune. Dr. Sunanda Mishra, Research Investigator, PRC, Lucknow. Dr. Mr. Akhil Kumar Singh, Field Investigator, PRC, Lucknow. Yeah, Sunanda, ma'am. Yeah, okay. Dr. Bashir Ahmad Bhatt, Director and Associate Professor, PRC, Srinagar. Akhil Kumar, please. Akhil. Next, Miss Madhu Bidari, Research Investigator, PRC, Bangalore. Mr. Ramesh V, Field Investigator, PRC, ISEC, Bangalore. Dr. William Joy, Assistant Professor, PRC, Delhi. Miss Sangam Singh, research investigator, PRC, Delhi. Yeah, yeah. Sorry, I forgot the name. Dr. B. Javed Ahmad Mir, research assistant, PRC, Srinagar. Yes. Dr. H.R. Channaki, field investigator, PRC, Dharwad. Mrs. Semen Koropka, field investigator, PRC, Dharwad. Dr. Manoranjan Mohapatra, research investigator, PRC, Bhubaneswar. Yeah. Mr. Rajiv Kumar Sahu, research investigator, PRC, Bhubaneswar. Dr. Dheeraj Megwal, research investigator, PRC, Udaipur. Dr. Notan Kumari, assistant professor, PRC, Udaipur. Dr. Savita Thakur Joshi, research PRC, Shimla. Savita ma'am. Yeah. With this, yeah. Now I request, so with this PRC participants completed. Now I request from PRC Vishakhapatnam, Dr. K. Srinivasa Rao, research investigator, PRC Vishakhapatnam. Mr. C.H. Padalu, research fellow 1, PRC Vishakhapatnam. Mr. T. Srinivasa Rao, research fellow 2, PRC Vishakhapatnam. And Sri D. Apparao, typist, PRC Vishakhapatnam. Next, Mr. S. Prasad Rao, attender, PRC Vishakhapatnam. Next, G. Tarun, research scholar, Department of Statistics, Andhra University. Next, M.V. Lavanya, research scholar, Department of Statistics. Next, Mr. Srinu Setti, research scholar, Department of Statistics. Next, H. Usha, research scholar, Department of Statistics. Next, Alex, research scholar, Department of Statistics, International Research Scholar. Exchange. Next, yes, Sumadevi, research scholar, Department of Statistics. Next, I would like to invite our students, first year students of MSc Statistics, Department of Statistics, Andhra University. K.N. Asha Devi. Next, N. Srinu. N. Srinu. Next, K. Tulasi. K. Tulasi. N. Sai Sri. N. Sai Sri. Next, G. Sai Sri Devi. G. Sai Sri Devi. Next, P. Devi Srinivas. Next, P. Varaprasad. P. Varaprasad. Next, P. Prudvi. Next, A. Swati. And N. Sri Harshita. N. Sri Harshita.
Now we invite Dr. Y. Ramana, Research Investigator, PRC, Andhra University, Visakhapatnam.
Now I request Madam Ms. Anjali Rawat to speak about this valedictory remarks. Yeah, Mr.
So I would like to take a feedback from you people. How was the first half of this today's training part? Though I missed because I had to attend a facility visit. How was it? Yeah. So the second part, which I think, sir, was basic of statistics and analysis. So it was good for the people who FIs and RIs who are working. So you require many more trainings like this? If yes, then you have to give me what you want. So this was your idea, I think. तुमने मुझे बोला था ना कि you want something on basics of नहीं basic Excel workbook पे काम करना or statistical packages. Something came from your side. So that was the idea behind this workshop. So it was Udaipur's idea. Now I want other PRCs also to give few basic training concepts or training ideas which you want us to conduct for you. Right? So maybe for more youngsters who are here, sir, like Bashi sir, madam, you people are already trained.
Yeah.
Please suggest.
Yeah, basically, when we presented our annual work studies this year, most of the studies are trying to use the qualitative data. But I can tell with authority that most of the PRC, even ours, even myself, even though I have spent so many years, we are not very much confident with the use of the qualitative techniques. So I would request the ministry to organize a workshop exclusively on the use of the qualitative techniques.
Okay. So you note kar lo, we'll see this. Secondly, I'll be sharing the last year's HMIS data for each state, not for all the states together to all PRCs, but for your respective state. Analyze their data. The lines are freezed as of now, but see if there are any issues. Give it back to me rather than sending it to the state. Okay. Because even if you send it to the states, they will take it lightly at times. We'll be sending DO letters from here to the MD and to the Chief Secretary. So whatever issues you find in 22-23 data of the state which we will share with you, bring out those issues to us. We will share to the MD concerned. Because I'll be opening the lines. That time they can change the data if required. So that is one activity which we'll do. Second, another workshop we'll be proposing somewhere after you start completing your PIP. So after October, because October is the deadline for PIP completion, and this time you don't have to travel much, I suppose. The travels have reduced, right? So we'll be able to complete by October. This year would be final review. Last year was a midterm review, which secretary had, an additional secretary had taken. That was midterm review. This year would be 2 years review. So your PIP findings would be very important. So I want to share with NHSRC before the meetings actually start. So October is the deadline for PIP. Please do that and share the reports. Please don't take extra time on PIP completion. Then you get another 6 months to complete your studies. It can be done parallelly. I'm not telling you to do only PIP and stop the other pan-India studies, but they can be done parallelly. But the focus should be complete your PIP as soon as possible so that you are free. Secondary studies can also be done together with the PIP? I don't think so. That is an issue. As soon as you complete your secondary studies, please send us so that we can see, analyze, and recommend changes wherever possible. Because if you send us very late, we also take time to do it and the whole process get delayed. So jitna jaldi aap mujhe bhejoge, utna jaldi we'll get it checked and then we can revert back with solutions or recommendations, whatever. Okay. And 4 pan-India studies of last year, we'll be making presentation before secretary this month, hopefully, because our secretary is retiring this month. New secretary has already joined. He's OSD as of now. If possible, both of them would be there in the presentations. So you should be ready. Kerala should be ready. And Dharwad and Delhi. 4 PRCs. 5. No, 4 here. 1 combined. Okay. So you should be ready with your presentations and we also need a proper brief, policy brief. I think you have already given one to us. We are looking into it. We'll try and get back to you to rectify and make a smaller brief. So we'll share that format to you. You have to fix your policy brief in that format. So all the 4 lead PRCs, the professors are not here, so kindly note and you can go and tell. Anything else we need to tell PRCs?
Maybe, ma'am, this would not wait till 31st for providing the results.
As soon as you finish, please send.
We start.
This is what I wanted to say. As soon as you finish your PIP, start uploading on the folders so that I can see and then we can keep on sending it to NHSRC. And if possible, give a recommendations in each of your PIP visit. Just don't fill the checklist and send it to us. Give a proper recommendation.
Make sure that your reports are being seen by you, not like simply forwarding of that. You please go through the reports and if there is any critical analysis, do that, revert back to the person who has already done that. And the report should look like report.
It should have recommendations, basically. Recommendations. And not general. Give something specific to that particular state, facility, district, whatever you want. So that it goes into their checklist. Otherwise, if you give just a generic that we should hold more immunization sessions, this is not going to make any difference. Give special justified comments.
Because everyone has to understand that now your reports are not only being seen by Statistics Division, it is being seen by NHSRC. Secretary himself is actually chairing the steering committee. So he will be actually looking at your reports and actually he is actually approving all your AWP studies. So he will also be looking and he is that kind of frame of mind. New secretary is very critical on what assignment has been given to you. So all reports should be in proper format and it should not look like just for the sake of doing a study you have done it. No, it should be very
this time,
thorough.
Again, it will be a little challenge for us because new secretary has come into picture. Now we have to show him what we have been doing. And he's more, I'll say, he's an administrative, both of them were administrative person, but his thinking process is something different. Yeah. Yes. So he's very clear on his concepts and he's very particular on research activities. I think thoda tough time aayega hamare liye, but then we'll be able to overcome if you provide us proper support.
The minister is also taking a review of PRCs.
Minister is also taking a review of PRCs. We've already prepared what we want to show him, but we are still, he'll be giving us time anytime. So that is another one thing. And please, seniors are not here, but I'm just pointing out complaints. There is a process of, if there is any complaint in any PRC, whatever reasons, there is a proper protocol that needs to be followed. First, you need to exhaust your key person, then your honorary director, then your registrar, your VC, and then the complaint should come to us if possible, and then you write to ministers. I don't know why people don't understand these protocols. There is a government protocol, how the complaint, if you have any kind of grievance, there is a procedure, there is a process which is written in the manuals. You need to follow up. What do you think if you send a complaint directly to minister, everything would be resolved? No. So it's just my suggestion because what we are here, it is not in the PRCs I'm talking about. It's a general statement. There are no complaints as of now in the PRCs, but it is a general trend which we are seeing in the ministry. Everybody thinks that if we send a complaint directly to the minister, the officers concerned would be pulled and pushed to resolve that complaint. But
If that
yes,
is the
we-
case, then there is no requirement of DDG, there is no requirement of Vice Chancellor.
Just to
You
give you
just
a-
approach directly to your minister and get everything done. It's not like that. In fact, for civil servant like us, if I have some complaint with my office, I have to first approach my DDG. If she is not in position to actually give a satisfactory reply, then I will approach to DG. And if he is not, then secretary, then minister. If I break the channel in any of my action, I am supposed to be punished. It is that in civil services. So there is a proper channel, there is a proper structure in every office, and I think you should if you have some grievances, you should first go to the next senior most person, whether he is able to not. If you are escalating something, it means that none of the person in the channel has been able to solve it. So you have to take care of that. So if everything start being done by DDG, then there is no point of having saying that the all administrative control are with the university or institute.
It's a general statement. I'm just mentioning because these are kind of things which are happening everywhere across the country after RTI has come. So RTI is a completely different platform. Grievance is a completely different platform. But if you're writing to someone in the ministry, a proper protocol has to be maintained. Just a request. There's a complete channel of officers everywhere. So follow that channel before you come directly to the minister. Any of you, means it's just a general statement.
Bypass of channel.
Yes, it is written. This is standard protocols. It is written in the Gazette everywhere. So I'm not telling anything which is.
It is in the conduct rule.
Yes, it is in the conduct rules of officers as well. I can't directly write to minister unless I exhaust my DG and secretary. I can't do that. If DG is not in the position and he is not listening to me even after 10 complaints, then I will approach the higher authorities.
At the practical aspect of this, if some complaint comes to us or ma'am, what we will do? We will forward it to your VC. Please give your comment. Ultimately, he will be actually examining your complaint. So your approach should be like that, and it will actually give you solution in lesser days. In fact, so
Okay, one achievement. Patna, who's there? Patna. So PRC Patna, we have got clearance for a 7 CPC. So that was a very big achievement which Dilip ji was looking forward to. So we've done that. I think we've issued the order also. So all the other PRCs whose 7 CPC is pending with us, if yes, then we are putting up the file by next week. If it is with you and you've not yet sent, please send it to us. So now there's clearance. IFD will approve it straight away. So
in fact, if your university has not taken initiative on 7 CPC, you actually request them to kindly send us to the proposals.
If it is 7 CPC is applicable to your particular university, they have already adopted it, then you may send a proposal for your PRC also to us.
No registrar.
That has to come through registrar. Anything.
I think since it is now the validity section, so I thought that on behalf of all the PLCs and on my own behalf, I am highly thankful to the ministry that they gave us the chance to have this joint workshop with the state officials. Actually, when this business of HMIS started, I was from the very beginning advocating that this should have been a joint workshop with the state people, because at that time we were doing a lot of analysis on the available HMIS data, and we used it to share with the state government. And since at that time the state government people were not very much expert in HMIS and PRCs were much more expertise, so they used to listen to us. But now they have become more experts than many people, so I don't know whether they will listen to us. And this is a very good suggestion that whatever analysis which we will be taking on this HMIS data, we will be sharing it with this ministry, and then they may be sharing it with the state government. And at the same time, I am highly thankful to our PRC team at Visakhapatnam, but in particular Professor Muswami and Dr. Ramana, for their whole efforts in making this seminar progress, and we couldn't see any fault in any of their organizational programs. So highly thankful to you for making, for organizing this in a very wonderful way. Thank you very much.
So I'll also take this opportunity to thank you, sir, and Professor Ramanna and your team. sir, wonderful arrangements. And we were impressed when my team had come last time for that population clock. Population clock, was it? Yeah, so my DG was also very much impressed. And when we gave the name of few PRCs, he picked out PRC Vishakhapatnam for this training. So thank you, sir. And thank you, Professor Ramanna, for organizing this. And thank you, everyone, to be present here. The next session would be in the university. That would be an hands-on session. So we thought that we'll complete the valedictory here before you have your lunch and move to the university. So any suggestions from the PRC? Otherwise, we'll close the session here. Well, it's 22-23 data, ma'am. The formats are old. 22-23 formats are old. From 23 April onwards, new formats are in the field. Okay. वही वाले पुराने वाले. You check the earlier, the ones which are already there, because there is no communication from NITI for change of data elements as of now. So whatever you're verifying, you keep on doing that. Yes. पुराना जो data elements हैं district hospital ranking के लिए, you follow them. That's it. Till we get anything from NITI Aayog. मैम वो नए फॉर्मेट्स हैं तब आई थिंक मैम वही बोल रही थी मैम न्यू फॉर्मेट्स आर लॉन्च्ड इन द फील्ड आपको समझ आया कल की वर्कशॉप में पुराने जो फॉर्मेट्स हैं वो मार्च तक ही एप्लीकेबल हैं फील्ड में ओके तो आपको जो मार्च इज 22-23 मार्च उसका डेटा हम आपको डाउनलोड करके देंगे एक स्टेट का आप उसको देखिए उसमें एरर्स निकालिए एंड गिव इट टू अस we'll send it back to the state telling them to change that data on the portal when I open my lines again. मैंने 22-23 की lines बंद कर दी हैं अभी ठीक है सो आप मुझे जो देंगे क्वालिटी इश्यूज आई विल सेंड बैक टू द स्टेट फॉर देम टू रेक्टिफाई व्हेन आई ओपन द लाइंस फॉर देम इट इज नॉट ओपन 23 अप्रैल से न्यू फॉर्मेट्स आर लॉन्च इन द फील्ड ये नए फॉर्मेट्स थे कल जो हमने दिखाए सर्विस डिलीवरी भी चेंज हुआ है इंफ्रा कंप्लीटली चेंज हुआ है इसलिए पीआरसीज को भी समझना जरूरी है व्हाट आर न्यू चेंजेस इन द सर्विस डिलीवरी एंड कंप्लीट चेंज इन द इंफ्रा Infra is as per latest IPHS. It is completely different. थोड़ा short है. Infra इस बार हमने reduce किया size. Service delivery का size increase हुआ है. So there are more elements in service delivery now. So there are new modules, new programs added. So आपको वो program खुद भी समझना है. So guidelines for each program are there on the websites. आप प्रोग्राम लिखिए यू विल गेट द होल गाइडलाइंस देयर डेटा डेफिनेशंस वी आर शेयरिंग हैव वी शेयर डेटा डेफिनेशंस विद द पीआरसीज हम आपसे डेटा डेफिनेशंस भी शेयर कर देंगे ड्राफ्ट डेटा डेफिनेशंस है व्हाई वी कीप देम एज ड्राफ्ट क्योंकि आप लोग सब फील्ड में जा रहे हैं एंड द स्टेट्स आर आल्सो गोइंग इन द फील्ड अगर लगता है देयर इज एन इंप्रूवमेंट इन अ पर्टिकुलर डेटा डेफिनेशन यू हैव टू टेल अस जैसे कल केरला ने पॉइंटेड आउट सम इश्यूज सो वी हैव ऑलरेडी रेक्टिफाइड दोस डेटा डेफिनेशंस इन द न्यू फॉर्मेट्स तो आप लोग भी जब फील्ड में जाएंगे यू शुड बी क्लियर ऑन व्हाट डेटा डेफिनेशंस आर अदरवाइज यू विल नेवर बी एबल टू असेस द फैसिलिटी हम लोग अभी देख के आ रहे हैं अभी एक फैसिलिटी वहां पे स्टॉक आउट रेट हम व्हेन वी सॉ 23 अप्रैल न्यू फॉर्मेट्स है स्टॉक आउट रेट पुराने फॉर्मेट में भी था हमने शुरू के 15-20 एलिमेंट्स देखे तो डेटा ठीक आ रहा था तो मुझे लगा ठीक है वी केप्ट दैट फॉर्मेट कि अब डेटा ठीक होगा देन आई वेंट टू द फार्मेसी तो मैंने दे आर यूजिंग ई औषधि आपको ये पता है स्टॉक आउट रेट आपको HMIS फॉर्मेट में डालना है तो कैसे डालना है यू डोंट हैव टू कैलकुलेट एनीथिंग यू हैव टू आस्क द स्टेट वेदर दे आर रनिंग एनी e-Sanjeevani, e-portal, e-Aushadhi or DVDMS. You have to take out the DVDMS score from that portal and enter into HMIS. So she showed me the e-Aushadhi portal they are using. But there was no stock out rate in the portal as such. वो कोई मेडिसिन जो स्टॉक आउट हो रही है उसका वैल्यू नहीं आ रही कितनी मेडिसिन स्टॉक आउट हो रही है और उसका रेट नहीं आ रहा सो व्हेन आई सॉ दैट अपलोडेड शीट उन्होंने सबने 0-0 मार्क किया हुआ है सो यही चीजें आपको पॉइंट आउट करना है व्हेन यू गो इन द फील्ड यू हैव टू चेक दीज स्टॉक आउट रेट इज वेरी इंपॉर्टेंट फॉर DH रैंकिंग उनका स्टॉक आउट रेट ही नहीं मेंटेन हो रहा तो हम समझा के आए हैं कि स्टॉक आउट ऐसे डलेगा So here is where I need PRC. So unless you know your data definitions, you will never be able to guide the field. और कहीं पे data definitions clear नहीं है तो वो आपको हमें बताना है कि ये clarity नहीं है field में. Like deaths on क्या था रितु जी deaths in the home. डेथ्स, होम डेथ्स, वेयर टू रिपोर्ट. सो वो लोग क्या कर रहे हैं, आउटरीच में रिपोर्ट कर रहे हैं. सो इज दैट करेक्ट, नॉट करेक्ट? So we got an idea. We've also got a letter from one of the state. Other causes. So when you're not clear, so you're putting everything in other causes. So there are conceptual problems of understanding at the facility. And you have to make sure when you're going in the field that the MO in charge is signing the sheet which is supposed to be uploaded by the data entry operator. So here also when we went, the sheet was not signed by the MO. He's just entering. Though the data was good, data was not bad. But I'm just giving an example that these are few things which you need to point out when you're going in the field. Just don't take their data and blindly accept that they are entering is correct.
अभी जैसे कल डिस्कस कर रहे थे न्यू फॉर्मेट्स, तो एक पीआरसी सागर ने इशू रेज किया था, तो आई वुड लाइक टू रेज इट टू ऑल पीआरसीज के whenever you will go to field, still you will find out some facilities they don't have the new format or might be reporting on old format. So इट्स नॉट लाइक दैट कि आप सिर्फ एक पॉइंट, एक नेगेटिव पॉइंट आप अपनी रिपोर्ट के पॉइंट ऑफ व्यू से सिर्फ आप नोट कर लें कि मेरे को इस पर्टिकुलर डिस्ट्रिक्ट में एक पॉइंट ये मिला है कि वहां पे रिपोर्टिंग फॉर्मेट्स नहीं थे. आपका काम यहाँ पे ये बढ़ता है कि आपको उस पर्टिकुलर स्टेट के कंसर्न नोडल ऑफिसर्स के साथ अटैच होकर के उनको डिस्कस करके you need to provide those new formats so that at least they start recording the new data elements in that particularly new format. तो rather than कि आप फिर 2-3 महीने बाद वो रिपोर्ट हमें भेजेंगे और हम 2-3 महीने बाद वो रिपोर्ट देखेंगे, तो उसमें क्या होगा कि वो एक पर्टिकुलर पॉइंट होगा कि वहां पे नया फॉर्मेट नहीं था. जब हम साल बाद हम पूछेंगे कि हाँ फॉर्मेट नहीं था, बोलेंगे फॉर्मेट तो अब आ गए हर जगह पे, तो उसका उस टाइम पे कोई रेलेवेंस नहीं होगा. रेलेवेंट अभी होगा कि आप अभी उसको रिजॉल्व करवा दें. तो ये चीज, ये सिर्फ एक पॉइंट है, ऐसे ही कुछ कुछ और पॉइंट्स भी होंगे जो आपको नजर आएंगे फील्ड पे. तो उसके आपको मतलब नेगेटिव पॉइंट्स लिखने के पॉइंट ऑफ व्यू से मत सोचिए, उसको सिर्फ आप रिजॉल्व करने के पॉइंट ऑफ व्यू से सोचिए कि आप ऑन फील्ड उसको कैसे रिजॉल्व कर सकते हैं. मेरा ये कहना था. थैंक यू.
जो राकेश जी ने बोला उसकी आगे वन लाइन मोर. Old formats were available, new were not available. So we informed this person and the work. थोड़ी report और बड़ी हो जाएगी.
Also tell them the new formats are available on the portal. When they log in, the new formats are available. आप खोल के दिखाइए. You all people have access to the portal.
Explorer पे चले जाओ. तो डाउनलोड्स में ना हमारे फॉर्मेट्स पड़े हुए हैं. अब ये दिखा देते हैं, जो भी लॉगिन करता है डाउनलोड्स में नए फॉर्मेट है. हम फॉर्मेट में जो भी चेंज, हमारे पास भी शायद पेन ड्राइव में पुराना होगा लेकिन वहां पर नया पड़ा हुआ है. तो अभी ये मैं एक बार दिखा देता हूं.
Yeah, I would second Rajesh ji. Actually, we also visited 3 districts. In the first district, we couldn't find the HMIS formats, but we contacted the concerned persons in all our districts and told them that we are coming to the districts to see whether these HMIS formats are available. So when we went to the second and third districts, they had already made available these formats, and that was probably one of the contributions which PRC made so far as the new HMIS formats are concerned. And we also requested all these people who are at the CSC level, PSC level, and subcenter level. We made them available the formats through their website, so we can even help them. It is not only that we are going; we are just going there only for monitoring. Our monitoring has to be supportive because we all work for the HMIS, so we have to be very supportive. And whatever good things they are doing, we should also highlight them in our reports.
Yes. So your work is assistance. Not only pointing out mistakes. Mistakes point out kariye, that's important, but to help them how to rectify. So please, you need to learn your data definitions. Rather than we are, see, states are over, you people are overburdened, states are overburdened with 10 to 20 portals in which they are entering the data. There were around 20 portals where I went. This person, only single data entry operator is entering the data. Usko lagta hai, just finish it off and go away. So the responsibility lies with the MO. Somewhere they are doing, somewhere they are not doing. So we are here to help them. That is the only concept behind this thing.
भी लॉगिन करेगा कि डाउनलोड्स में जाते ही ना सबसे ऊपर ये रिवाइज्ड HMIS फॉर्मेट्स पड़े हैं. अभी हम इसमें वो भी डाल देंगे, इंफ्रा के फॉर्मेट्स भी डाल देंगे, एंड एज वी आर रेडी विद वन सेट ऑफ गाइडलाइंस फॉर डिस्ट्रिक्ट हॉस्पिटल. आई विल डिस्कस विद राकेश. अभी ये पीआरसी वाले ग्रुप में हम डालते हैं हम लोग डीएच में ना.
I just want to ask, how many RIs and FIs have first time come for HMIS training here? First time. Okay. But you have seen the portal? Okay, you have gone for the physical verification. Infra का data कब enter होता है? New RIs, FIs. Please tell me how many times it is entered in a year? Just last question from my side. कब डालते हैं? स्टार्टिंग में, एंड देन नेक्स्ट मंथ क्या करते हैं? सो कोई फीचर है पोर्टल में? कैसे कंटिन्यू होगा? मतलब 200 एलिमेंट को देगा दोबारा डालेगा? हाँ, क्या करते हैं? एनी अदर? सो दैट मीन्स you need to have more training on the portal. Please open this. Your PRC is having user ID passwords. Ask your key person. They are all trained. There is a provision of auto forward. Yes. So I'm just giving you a very small example. Unless you know the portal, unless you know the data definitions, your role will not come into picture. So if you want to play an important role, you should be very much clear on what portal is giving you. Right? What kind of reports? So new reports will come. We've not yet, we stopped everything for the time being because we're focusing on data entry module. Right? Okay. So if any more training is required by any PRC only on HMIS, please connect with us. एक दिन की virtual training करेंगे 2 घंटे की. We'll finish it off there and then. So go back, think over and let us know.
ट्रेनिंग कंडक्ट करा रहा है HMIS के लिए, तो उसमें जा सकते हैं क्या?
बिल्कुल जाइए ना, किसने मना किया? तभी तो आपकी लाइसेंसिंग करवा रही हूँ मैं यहाँ बैठ के.
मैम यही है कि एक लेटर अगर आपकी तरफ से आ जाए
Okay, we'll send a letter. As soon as we get an information that state is conducting, we'll involve PRCs और एक general letter भी हम भेज देंगे.
जी बिल्कुल.
ठीक.
स्टेट लेवल पे और डिस्ट्रिक्ट लेवल पे.
Right.
डिस्ट्रिक्ट लेवल पे हम लोग अगर.
So, but then you will be trainers. You will not be participants.
नहीं, ट्रेनर्स में.
Yes. Trainers. I'll send you.
हम लोग एक आपको भी रिपोर्ट भेजें कि ट्रेनिंग में क्या क्या कमियां आ रही हैं.
Sure.
या फिर जैसे कि मैडम हमने देखा है अभी जो ट्रेनिंग हो रही है, तो प्री टेस्ट पोस्ट टेस्ट एक पोस्ट टेस्ट हो जाए कि क्या क्या डेटा डिफिनेशंस हैं ये भी.
ठीक है.
या मैडम एक बात और पॉइंट आउट करना चाहेंगे कि पहले HMIS ठीक ढंग से चल रहा था, जो ब्लॉक लेवल पे वैलिडेटिंग कमेटी बनी थी और उसकी मीटिंग होती थी, लेकिन वो अब बिल्कुल देखने को नहीं मिल रहा है. कागज पे तो वहाँ 4 मिनट्स लिख लिए साइन हो जा रहा है, लेकिन डेटा वैलिडेशन कमेटी ब्लॉक लेवल पे ठीक ढंग से हो तो एरर वहाँ
देखो, मैं I can only suggest the states to do that. I cannot do micromanagement at the block level. दो मैं हर मीटिंग में बोल चुकी हूँ. हमने अभी 3rd रीजनल वर्कशॉप है. हर रीजनल वर्कशॉप में मैंने बोला है कि प्लीज कंडक्ट कमिटीज, वैलिडेशन कमिटीज, peer checking करो, facilities, district peer checking करो. These are suggestions from my side which is already gone. But if states are not following, I really can't do micromanagement at the state level. But you can liaison with the states and tell them to do this. We'll also write again. That is only one thing I can do. So, yes. नहीं, आपको करना है, send me a mail. I want to conduct a virtual VC with the HMIS team. आपके लिए एक टाइम स्लॉट हम बुक करेंगे. Send me a mail because I need to know which PRCs are still not comfortable in HMIS. Because you need to be comfortable now. What time हो गया? You are there for HMIS monitoring. 5 PRCs have been selected for NFHS monitoring as well. So next year, we hope we get post filled and we expect more PRCs to work for NFHS. So धीरे धीरे we have to build our system strong. Otherwise, we'll be out of the mainstream. And this is the effort towards that. So start focusing on what is it. And please also, the PRCs are not involved in NFHS may also build up their literature, start learning what is NFHS. Maybe in coming next year, you will one of the PRCs were involved in, because we are going to do on the rotational basis. This time 5, next time maybe another 5 or 6 will come into picture. So start learning about what is NFHS, not only HMIS. Both the systems, both the administrative and survey data are important. Even for your research studies, it is important. Okay. So we.
इनफैक्ट अखिल जी ने एक पॉइंट जो रेज किया कि वैलिडेशन कमेटीज का, तो मेरे भी माइंड में ये आया कि क्योंकि आपका स्टेट बहुत बड़ा है ना, तो एक क्यों ना एक स्टडी आप कुछ छोटी सी स्टडी एक ऐसी प्लान कर लें ऑन फंक्शनिंग ऑफ ब्लॉक वैलिडेशन कमेटीज, ठीक है, तो हमें भी कुछ एविडेंस मिल जाएगा एंड हम भी उसको हम स्टेट्स को हम लिख देंगे सो दैट के उसको और स्ट्रेंथन कर सकें।
ये आपका एक उनकी पॉलिसी में इंटरवेंशन हो जाएगा कि देखो आप करते नहीं, इट्स ऑल ऑन द रिकॉर्ड्स, नथिंग यू आर डूइंग, तो करिए, दैट्स अ गुड आइडिया, अदर्स कैन आल्सो थिंक ऑन सिमिलर लाइंस। Okay, so we close the session. Thank you so much for patient hearing, and thank you so much, sir, and Professor Ramanna for organizing this training. Thank you so much. Thank you.
So time is getting late. Just I wanted to express our gratitude on behalf of PRC Visakhapatnam. Madam, from PRC Visakhapatnam, we are very grateful to the Statistical Division, Ministry of Health and Family Welfare. You are so kind of towards PRC Visakhapatnam. We are very much grateful to you, ma'am, because you are supporting us at every time. Because though we have a few staff members, but we could able to do along with all PRCs at our level best. And we are very much thankful to sanction this major 2 days workshop to our PRC Visakhapatnam on behalf of our Honorary Director and our Andhra University Visakhapatnam. We are very much grateful to you, ma'am. And the university is also equally providing such a support. Our Vice Chancellor, Prasad Reddy sir, and Registrar sir, and Rector madam and Principal sir, they are also equally, whatever the file, whatever the letter we requested, definitely they'll immediately they'll forward their file. Even though we are also very thankful to the university administration. And coming to our PRC, our Honorary Director sir, though he is very busy with as head of the Department of Statistics and some other additional responsibilities, but he could able to monitor every day what things are going on. And our team, Dr. Srinivas, Padalu and T. Srinivas, Appara and Prasad, we are 7 people, we are in a common platform, we are planning and everything, we could able to do everything. And regarding this workshop, research scholars, our Department of Statistics and students, so they have supported well, and we could able to organize in a very good manner. I think if any mistakes, any inconvenience from our side, please excuse us, please, because since the very short time, but we people are take it as challenge, how best we could able to organize the program. So I thank each and everyone from the ministry side and from university side and from our PRC, and particularly the PRCs, 18 PRCs from all over India and 10 states from all over India. So they have participated, they are cooperated well, they are mingled with us since yesterday and for 3 days. I thank each and everyone, heads and directors of PRCs, as well as state HMIS teams, state representatives. And I thank our IT experts from Andhra University, and even the hotel managers, banquet hall manager, hotel managers, they are also very cooperative. So I thank each and everyone who have directly, indirectly supported us as part on behalf of PRC Visakhapatnam. Thank you very much.
Wonderful arrangement.
We have a lunch here, and after lunch we will have a practical session. So the bus is available in the after lunch in the hotel. So we will go by Andhra University bus to the Department of Statistics. Then we have a practical session over there. Then it will be over. Thank you.